Hello everyone and welcome back to today's new tutorial topic. So today I'm providing definition and the importance of the data structure in Python programming and properly explain for in this topic. Okay. So here I'm properly defined and I hope you perfectly understanding this topic. Okay. So first of all here I'm explain for is a so you can say first of all define the definition of in this the data structure. Okay. So data structure is a specialized format for organizing, processing, retrieving, and storing data, and is defined a particular way to manage and store data in a computer so that it can be used for efficiently. So data structure can be simple like array and a list or complex like tree and the graphs. Okay. And next I'll explain for the importance of data structure. Okay. First important the topic is the efficiency. Is a two type. First is the time complexity and the space complexity. First I'll explain for the time complexity. Okay. So the time complexity is different data structure offer different time complexities for operation like searching, inserting, deleting, and updating data. Choosing the right data structure can significantly for affect the performance of your program. And next we'll explain for the space complexity. Okay. So efficient data structure helps in the reducing the memory footprint of your program, which is crucial for handling large data set. And next I'll explain for the another important data structure like the data management. First on the organization. So data structure help in organizing data in a way that allow for efficient the retrieval and the manipulation. Several examples for is a list and the dictionaries helping storing and accessing data efficiently. Next, I'll also explain for the another importance for the data structure like the code simplicity. Okay. First word here is the readability, second the maintainability. So readability using the appropriate data structure can make your code more readable and easier to understand. So for example, for using a dictionary for the key value pairs is more initiative than using a list of tuples. And next to explain for here is the maintainability. So well-chosen data structure can make your code easier to maintain and extend and help in managing the complexity by abstracting the underlying data management. And here I'm also explaining for is a problem solving. Algorithm implementation. Many algorithms are designed with a specific data structure in mind. For instance, the graph algorithms rely on graph data structure and sorting algorithms often used for the array or the list. Okay? And next I'll explain for the also common data structure in Python. First on the list, tuple, dictionary, and the same. And here I'm simply explaining for the list. The list is an ordered collection of items that can be changed immutable and use cases for the general purpose storage of items. And second for the tuples. So ordered collections of items that cannot be changed for the immutable. Use case for the fixed collections of items like coordinates. And also here we explain for is the dictionaries. So dictionaries is an unordered collections of key value pairs and in the dictionary use cases for the first lookups as your associative array. And next we'll explain for here is set. Set is an unordered collections of unique items. Use case for membership testing, eliminating duplicates. Okay. And next I'll also explain for the another common data structure like queue, stack tree, and the graphs. Okay. So here I'm simply explaining for in this the queue and also explain the use case. First of all, the queue. is a collection that follow the FIFO for first in, first out principle, and the use case for scheduling tasks, break first serves, and also the stack. The stack means is a collection that follow the LIFO for the last in and the first out principle, and the use case for the undo mechanism depth first search. And next time explained for here is a trees. The data structure is a hierarchical data structure like the binary tree and AVL trees. Just like the use case for the hierarchical data representation, efficient searching. And last time explained for here the graphs. Graphs means the collections of nodes like the vertex and the edge. And the use case for the network representation, shortest path algorithms. Okay. So here, this session I properly explained for the importance of data structure and the definition. So now just like choosing the right data structure in the crucial for the efficiency and the performance of your program. It directly impacts on how well your algorithms perform and how the maintainable your code in and understanding the various data structure available in Python and their use case will help you write more efficient and effective. Okay? So I hope you properly understanding in this today's tutorial topic for definition and the importance of data structure. Okay. So now just thanks for watching and happy coding. Hello everyone and welcome back to today's another tutorial topic. So today's topic for the overview of algorithms and their applications. Okay. So this tutorial I'm perfectly tried is completely done for this today's tutorial the overview of algorithms and their applications. Okay. So now let's get started. So you can see first of all I am here is explained for the overview of algorithms. Okay. So algorithms are the step-by-step is procedure or formulas for solving problems or the performing tasks. They are central to computer science and programming because they define the logic required to solve problems efficiently. And in this Python, its algorithms are implemented to handle a wide range of tasks from basic data processing to complex machine learning models. And here is an overview of algorithms and their applications in Python. Okay. So first of all, here I'm overview the algorithms for the sorting algorithms. So in this algorithm just used to arrange data in a specific order like ascending order and the descending order. And here I provide for the simple example for bubble sort, merge sort and the quick sort. Bubble sort is compare adjacent elements and swap them if they are in the wrong order. And the merge sort is divide the list into the halfways. Sort is half and then merge the sorted halfways. And the quick sort is provide the selector to pivot element, partitions the array around the pivot and recursively sorting the sub-array. And here I'm also provide for the applications for organizing data for easier access and preparing data for further analysis or processing. Okay. And next topic here I will create another example for searching algorithm. So in this the algorithm just used to find a specific data within a data set. Okay. So now I'm provide for the two examples for linear search and the binary search. So linear search means the sequentially check each element of the list until the desired element is found. And the binary search for efficiently finds an element by repeatedly dividing the search interval in half the required stored data. And here I'm also explaining for the applications. So just looking up values in a list or database and implementing search feature in applications. Okay. And next I'm also explain for the graph algorithms. Okay. So in these algorithms used for traversing or analyzing graph for data structure. In this the graph is three types: depth first search, breadth first search, and the best clusters algorithms. So here I'm explaining for the three this type. So first to explain for the depth first search for the DFS is explored as far as possible along each branch before the backtracking. And also for explain for the breadth first search for the DFS, explore for all neighbors at the present depth level before moving on to nodes at the next depth level. And next time explained for here is the discussor's algorithms. Find the shortest path from a single source to all other nodes in a weighted graph. And here I also explain the applications. So, like the social network analysis and the route finding and the network optimization. Okay. And next topic here I'm also explain for the another important algorithm for the dynamic memory algorithm. Sorry, it's dynamic programming algorithms. So these algorithms used for optimization problems by breaking them down into the simpler sub-problems and storing the result to avoid for the redundant work. Like the example for Fibonacci sequence and the here is a kind of big problems. Okay. So first I'm explaining for here is a Fibonacci sequence. Is a compute Fibonacci numbers by storing previously computed value to avoid the recomputation. And next time explained for here is a knapsack problems for solve the problem of maximizing the total value in a knapsack without extending its weight limit, like the application for the resource allocations and the financial modeling and the optimization. Okay. And here I'm lastly explain for another most important algorithm for the Python programming language, like the machine learning algorithms. Okay. So this algorithm just used to training models that learn from data and make a prediction or decision. Like the example for the linear regressions, decision trees, and the K-means clustering. So first I'm explain for here is the linear regressions. This model, the relationships between a dependent variable and one or more independent variable. And next I'm explain for the decision tree. So the model of decision and their possible consequence using a tree-like graph, and the K-means clustering groups data into K clusters based on features simply is a similarity. And also here I'm explaining for the applications like the predictive analytics and also the classification and the clustering of data. Okay. So that's it for the today's tutorial, and here I am perfectly explained for the most important uses algorithm and also for the applications. Okay. So in these, the algorithms are the crucial for solving a wide range of computational problems efficiently, and in Python they are implemented to handle here the various tasks such as sorting, searching, algorithms, or here is a graph traversal, optimization, and the machine learning. Okay. The understanding and applying the right algorithms for a given problem is to key developing effective and efficient solution in programming. Okay. So now that's it for the today's tutorial, and the proper explain an overview of algorithms and their applications in Python programming. Okay. So now just thanks for watching and happy coding. Everyone, and welcome back to today's another tutorial topic. So today I'm creating here just refresher on the basic Python programming tutorials. So today I'm just create here the fundamental concept in Python programming, and either you are the new to Python or just revisiting, this will be a helpful overview. Okay. So here is a refresher creating the Python programming starting. So starting for the Python programming topic for the variables, data types, conditional statement, and also for the loop. Okay. So this session I'm create for the basic Python programming example topic. So first of all, here I'm create the variables and the data type. Okay. So you can see here, first of all, I am open for here is a PyCharm, this community version code editor. It's a free version and here used for in the code editor used for the best platform. So you can see, first of all, I am create the starting example for the variables. Okay. So you can see, first of all, here I'm defined for the variable is a name and is equal to defined for the value is a Gmail. Okay. And then I also create here the another variable for age is a 26. Next time also created for the another variable, the height is equal to 5.4. Okay. Let's make this properly created in this example. And you can see here I'm defined for the symbol of variable. Okay. And now I'm print for the values and the type. So you can see here I have this print function, this inside and include for here is a name. Okay. And then here I'm also defined for the variable of the name. And secondly, I'm used for again the string function, and here I will include for the perfectly indeed the age and define for is a symbol of is this variable. Okay, so you can understand it is the age. And also here with another print function this inside and include for here the height. Okay, and define for is a height this variable. Okay. That means here I'm properly defining for here is a three variable like name is a string type, then is an integer type and the height is a float. Okay. And indeed the Python is automatically assign the data type based on the value you and here and provide. Okay, so you can understand it. And now just I'm perfectly saving this all code and just click on in these are run buttons. Okay. So now as you can see here, you perfectly see the result. Supposed to the print the name, Jamie, and they just 26 and the height is a 5.4. Okay. So you can see here the perfectly declaring and show the output for the variables. And next time also created here is the data types. Okay. So if you can see just go in the next line of code. And first of all here define for the data types. So you can see type of the print function. So this inside. And first is type for here is the type of the name field. Okay. And now just use for this the type this method this inside I mean include for the variable of a name. Okay. And next time again use this another print function this inside and print here the type of the age. Okay. And now I'm just declare is a type this method this inside and include for the variable of age. And again use the print function and this inside and just again typing for the type of in this the height. Okay. And now this is properly used into the type this method and here include for into the height. Okay. That means here in this type function helps us check the variables of type. Okay. So you can understand it and now this time properly saving this again in this code and just click on in this run buttons. Okay. So as you can see here the perfectly and automatically generate the type of the name is a string type, the is for the integer type, and the height is properly is a floating type. Okay, that's what is properly done in these the variables and the data types. And also we are creating for the refresher the Python programming topics for here is the control follow. So here I'm using for the if else statement. Okay, so now let's see in this example. So you can say first of all I am removing for ending the all code. And first to define here the variable like is score is equal to 85. Now I'm used for the if else statements. You can see here I'm type for if and declare the variable of the score is greater than equal to 90. And now I'm used for into the print function and this inside I am include for here the grade. Okay, you can understanding and here I am create for the grade of so is 85. So first of all, we are type for the grade for in class. Okay, and then I am create for so apply for is if. Sorry, I'm just type for in this the else if statement. And here for the again this condition for is the greater than is equal to is a 75. Okay, and then here is a print for the another grade. So you can see I'm here is the type for the grade of A, the grade of A. Okay, so next I also created for here is the else statement. You can see and then just in the next line of code. And first of all here I'm type for is a print function. Okay, so you can see here I'm type for into the print function and this inside and include for here is a grade. Okay, the non-grade for is a B. So that means here I use for is the A minus. Okay, that means it's perfectly great now. So in this example, perfectly here I use for the if else statement to control the follow based on the value of the score. And here is the depending on the score value and the Python is print out the corresponding grade. This kind of control follow is essential for making the decision for in your code. Okay. So now I'm just properly saving this all code and just click on release the run button. So as you can see here, the properly the grade of A. That's what's perfectly done the student's tutorial. Okay. So you can see here and there's a quick refresher on the basic Python programming. And here I properly cover the variables and the data types and also the control follow with the equals statement. So these are the building blocks for any Python project. So now just thanks for watching. Hello everyone and welcome back to today's another Python tutorials topic. So today we are creating and explore for the some common operation you can perform are list and the tuples in Python. So list and the tuples are the fundamental data structure and understanding for how to work with them is essential for any Python programmer. Okay. So you can start just starting for the program for accessing elements in list and the tuples. Okay. So now let's create. So first of all here I'm defining for a list and a tuple. So first of all here I'm type for is a my underscore this is a list and is equal to so here I'm just inserted for the sum of element. So first of all here I'm type for 10, 20, 30, 40 and the 50. Okay. And next I'm also created for the tuple. So just going the next line of code and here I'm type for my underscore is a tuple and is equal to so here I am create for the sum of tuple. So first of all here I'm type for the 5 and secondly here I'm type for is a 5 then 15 then 25 and the 35 and also for here is a 45. Okay. And now going for and just accessing for the elements by index. So you can see here I'm type for this print function. So first of all here I'm print for the list. Okay. So here I'm type for is a first element and then I'm create this clone and then define for is a my list and here I'm use for the index of 0. And next time we can use the spring function and this inside and include for here. It's perfectly this tuple. And then define for here is a last element. Okay. So you can understanding is create the last element and defined for here is a my tuple. That means in this example, first of all here I'm create the list for the my list and the tuple for here the my tuple. And in this Python system, you can access the elements in both list and the tuple by their index. And you can see here the positive indices start from the beginning 0 based, and while the negative indices for is start from the end, the negative one is the last element. Okay. So I hope you perfectly understanding this example, and now just I am save this properly and just click on this the run. Okay. So now just can see the results. Supposed to print the last, and hit the list is the first element 10, and the tuple for the last element for you can see the 5, 15, 25, 35, and 45. Okay. Here's one just perfectly create now this example. So here is a done, and next topic here I'm also creating is a slicing list and the tuple. Okay. So here I'm first to define again the list and the tuple. So you can see here I'm just randomly use for the number of 11. So you can see first of all that for the 6, then 99 and the 45. And also here create the 66, then 78. And here I'm just type for the 62. And then I create for the my tuples. So here I'm just begin the randomly. So first of all here I type for the 6, then 11, and then 25. Then apply for here the 39, and also here is the 40. Okay. That's was perfectly great. And next step here, I'm just going for in the next line of code. And you can see first of all here I'm type create the slice operation. So you can see here first of all I'm type for the list. So you can see type for the list is slice is equal to define for is a my list, and this inside I create for 1 and the clone for 4. Okay. It's from index from 1 to 3. And instead create here is a tuple underscore in this the slice is equal to calling for here the my tuple, and then create a square bracket inside I'm included for in this string. Okay. It is a perfectly great. Now just use for the string function. And here first of all I'm type for is a sliced list. Okay. And also here I'm created just remove for the my list, and here I'm apply for is the list of slice. And secondly, here I'm create for the slice tab. Okay. So you can understanding, and here I'm type for is a sliced for in this the tab. Okay. And now I'm remove for in the my tuple. So here I'm include for is a tuple slice. That space is perfectly great now, and this example here I'm properly perform the slicing operations on both the list and the tuple. So slicing allow us to extract a portion of a list or the tuple for here the my list for 1 and clone 4, and extract for the element from the index for 1 to 3. And why? Indeed, the my tuple for the 3 extract element from the start to index of 3. Okay, that means is properly create indeed the slice operations. So now just I'm properly saving this all code and just click on in this the run buttons. Okay, so now just see the results as you can see here perfectly great. You can see the slice list for the 99, 45, and the 60. 6, and the slice tuple for here the 6, 11, and the 25. That means it's properly working in this example. So, and there's a brief overview of the some key operations on list and the tuple. So here I'm properly covered for how it says and the slice elements. Okay. So in these tab is properly creating this concept will help you work efficiently with Python data structure. Okay. So now just thanks for watching and happy coding. Okay. Hello everyone and welcome back to today's another tutorial topic. So today I'm creating an explore for real world use case and applications of Python programming. So throughout here I'm used for the best practical example. So from the data analysis to web scraping, the Pythons is versatility makes it a favorite among the developers. Okay. So you can see first of all, I'm creating the example for data analysis with the pandas is the most usable library package. Okay. So in the data analysis, a common use case for Python and the pandas library is widely used to this purpose. And here I'm creating a simple example of loading, analyzing and filtering data using for the pandas. Okay. So first of all here, I'm just click on the data and just create the example for the data analysis. Okay. So first of all here, I'm import for the pandas, the library package for SAS then PT. Okay. And now the create here is a simple data. So just type for the data is equal to, so this inside. First of all here, and type for the column is a name. Okay. And next time import for the some name. So you can see first of all here and type the first name is a Alice and the second person name like a Bob and the third person, sorry. So here type for the name is a Carolee. That's it. And also here I'm create another. So not now here. So properly here I'm type for is a David. So you can see here I am defining for the 4-person name. Okay. And next I'm create here is a age. Okay. So you can see here. And now I am set for here the age. So just I'm going for here. And then I am inserted for the 4 type age. So first I'm type for the 25, then I'm applied for here is a 30, then 35, and next time create here the age is a 40. Okay, is a perfect. And next time create for the another column. So you can see, sorry, first of all here I'm taking the single quotations and then inside I'm type for the salary in this column. Now inserted for the salary amount. So you can see, first of all here I'm type for is it 50,000, then apply for here is a 45,000, then create for here is a 55,000, and then apply for here is 60,000. Okay, that's also perfectly great now. The next step here, I'm create is perfectly the data frame. So you can see I'm type of the df that is equal to that the pd dot apply in this the data frame. Okay, so you can see here I'm create the data frame and this inside and include for in data is the data. Okay, so just type for the symbol of data. And now I'll create the filter data for people with salary above for here is 60. So now, first of all here and type for is a, this is a high, sorry, mistakenly click now is a perfect high earners. Okay. So you can see the high earned is equal to define for the DF. And this inside I will include for again this DF and define for the column is a salary. And now I'll create for here is a greater than for the 60,000. And you can see here I'm apply for is update for the salary. So just go over here and change this one. So first of all apply is 50. Then here I'm type for is a 70,000. And here I'm import for here is a 80,000. Okay, that's perfectly done. I'm just going the next line of code. And here I'm type for the output function just like a print. This inside I'm include for the high earners. Okay, that's why this perfectly here and create first is create a simple in this the data frame. And then the first people who have a salary of more than 60,000. Okay. So now first of all, I'm checking with the output. So save this all for and just click on in this the run buttons. So now just read and see the results. So you can see here perfectly print for the high range salary. First person name is Bob as 30 and the salary amount for the 70,000. And the second high salary ranger person, the Charlie, and it was 35 and the salary is a 80. Okay. So 80,000 is perfectly here. That means the result display the names and the details of individual who meet the conditions. Okay. So I hope you understand it in this tutorial. And next topic here, I'm also created for the applications for web scraping and the beautiful soap. Okay. So now just here, I'm remove for this code. And first of all here, I'm just explore the web scraping. The Python is often used to extract data from website using libraries like Beautiful Soap, and here I'm using an example of scrapping a web page and retrieving for the headlines. Okay, so you can see first of all here I import for the library package is a request. Then I'm use for the from, and also here I'm type for the B, and then S the for, and then import for here is a just type for is a beautiful soap. Okay, so you can understand is it properly defined a beautiful soap. And now page for the web page. So you can see here I'm type for the URL and is equal to the single quotations, and here I'm type for is the link for the web address, the HTTP dash and then forward slash and then type for is a properly google.com. Okay, so you can understand it. And now just one type for here is a response. Okay, so response is equal to define for the properly request dot apply in the get and this inside and include for in the URL. Okay. And also here I'm create the first the HTML. So you can see here I'm type for the soap is equal to define for the beautiful soap, and this inside I include for here is a response dot the text. Okay. And also here I'm declare the file is a HTML dot is a parser. Okay. And next I create the find all headlines for these two tags. So here I'm type for the headlines and is equal to type for the properly soap dot apply in this the find underscore this is a all method, and this inside I'm include for here is a h2. Okay. And next I create for the output section. So you can see here I'm type the for loop, and here I'm define for the properly in this the headline in the headlines. Okay. And now we'll use for the properly into the print function, and this inside first of all I include the headline dot apply in this the text method. Okay, that's what is properly created in this example. And here I first of all use the request to fetch a web page of beautiful soap to first to the is the HTML content. And then I start for the all for the H2 tag, usually headlines and the print their text. And indeed the Python makes the web scraping effortless, allowing you to automate data extraction from any website. Okay. So I hope you proper understanding this application. So that's it for the today's tutorial. And here I'm properly highlight just a few of Python's many use cases from the data analysis to web scraping. Okay. So Python's simplicity and the power make it an essential tool for wide range of applications. Okay. So now just thanks for watching and happy coding. Hello everyone and welcome back to today's another tutorial topic. So today I'm going to deep into the stack data structure and how to implement it in the Python. So a stack is a fundamental data structure that operates on a last in first out for the LIFO principle. And here I am explore for the three key operations for the push, pop, and the peek with the Python code example. So now let's get started. So you can see first of all here I'm implementing a stack using a list. Okay. So the stack implementation using a list. So you can here. So first of all here create a stack. Okay. So you can see here I'm type for this is a stack. So stack and use for the equal to the empty. Okay. And next here push the elements on to the stack. So you can see first of all here I'm type for stack dot apply for in this the append. This inside and include for the number of element of 10. And this again type for the stack, then apply for in this append, then another element is 20, and again use this stack dot apply in this the append and this inside and include for the 30. Okay. And now here I'm create the print the stack. So you can see that the print function. This inside and include for here the stack after the pushes. So you can see and then create clone and just I'm call for the variable for it is a stack. Okay. That means here in this Python list to implement a stack and you can see this append method allow us to add the elements the stack. And the stack is known as the push operation as push for the number of elements 10, 20 and the 30 and they are added to the end of the list and which represent the top here is the top of the stack. Okay, so you can understand it and now just save this properly and just click on release the run buttons. Okay, so as you can see here is a perfectly print the output for the stack after pushes the value is 10, 20 and 30. Okay, it's perfectly done is a add method. And insisted here I'm creating the popping method is just element from the stack. Okay, so you can see just going the next line of code. And first of all here I'm create the pop elements from the stack. So you can see here I'm type the pop it underscore this event item and is equal to here I'm type a stack dot apply in with the pop this method. And now I'm here is the print the pop item and the stack. So you can see here I'm type this print function and then type for here is a properly defined. This is a popped item. And now here I'm stage for is a perfectly this is a popped item. And again create this print function and here I'm type for is a stack for after the pop and now I'm declare in the symbol of stack. That means here I'm perform the pop operations using in this the pop method and this remove and return the element of the top of the stack and this is the last element added and in this the case for 30 is properly removed after the pop the stack contains the remaining elements. Okay. So now first of all save this properly in this code and just click on in this the run buttons. So and you can see the result is perfectly print and remove the pop item for 30 and the stack after the pop is only stay for the two element for the 10 and the 20. That's just perfectly popped the stack item. Okay. And next topic here I'm also created the P at the top element of the stack. Okay. So you can see I'm also in the next line of code. And first of all, here I'm type for P at the top of the stack without removing. Okay, so you can see here I'm type for the top underscore this is the item and is equal to type for is properly into the stack and then decrement for 1. Okay, and now print the top item and the stack. So you can see here I'm type the print function and this inside and include for is a top item. Okay, and then call for, you can see here the top item. And next time again create the sprint function and this inside and include for here the properly stack after this the peak. Okay. And you can see here I'm typed properly in the stack. That means in this example, here and create the peak operation just allow us to view the element at the top of the stack without removing. And using the Python can do this by accessing the last element use the stack decrement 1 and after picking the stack is written is unchanged. Okay. So you can see first of all I'll save this all code and just click on in this the run buttons. Okay. So now let's see the outputs as you can see first between the top item is 20 and the stack after pick for the 10 and the 20. That means it's perfectly done. Okay. So you can see. So and that's a quick overview of the stack data structure and here I'm properly create and implement a stack in Python using a list and explore the fundamental operations like push, pop and the pick. And you can see here that the stacks are widely used in algorithms like for the DFS and the backtracking. So understanding them is key. So now thanks for watching and happy coding. Okay. Hi everyone and welcome back to today's another tutorial topic. So today I am implementing here a stack data structure using the Python list. So the stack is simple but powerful, following the last in first out principle and the cover the basic operation for the post, pop and the pick. So now let's get started. So this session I'm creating the stack using the list. So first of all here I'm creating the example for pushing elements onto the stack. Okay. So you can understand first of all here I'm initialize an empty stack. So just in time for the stack is equal to use the empty. And now first is create the push elements onto the stack. So you can see first of all I'm type for the stack and use the append method. This inside I'm include for the file. Okay. And next time again use the stack dot apply into the append then include for here the value is 10. And again define the stack dot apply into the append and include the value of a 15. Okay. And now just I'm displaying for the stack. So you can see. So first of all is perfect. And then I'm used for the properly print function and here I'm type for is perfectly this is a stack after. So you can see type for after is a pushing the elements. Okay. So you can understand the elements and now just call for the symbol of the stack. Okay. That's what is perfectly great. Now just save all and just click on these the run buttons. Okay. So as you can see here, you perfectly see the output for the stack after pushing element for the 5, 10 and 15. Okay. And next topic here I'm also just create another example for pop an element from the stack. Okay. So you can see here this next line and this type for the stack dot apply in the pop method and now I'm again use the spring function and then type for the again the same output message for stack after the popping is differentials and the element. Okay, so you can understand and then define the is perfectly this stack. You can see here first of all I initialize here the empty list called the stack and use for this is the append method to push element onto the stack and then use for here the pop method to remove the last element that was added and following for here is a LIFO order. Okay. So now let's see the output. So you can see just click on. So you can see here you perfectly see the result for the stack after copying an element for the 5 and 10. Okay. So it's done. And next topic here I'm create another example for picking the top element of the stack. Okay. So you can understand here I'm just create for again, just go in the next line. And first of all here, I'm just create, okay, so here I'm doing for in this all code. First time have this tag is equal to, so here I'm not empty and import for the number of elements, okay. And now here I'm just pick the top elements. You can see here on top underscore. This is the element is equal to, here I type for this tag and the decrement for 1. Okay. And now here's the spring function, and here I am type for the message like top element. Okay. So of the stack. You can understand it perfectly, and then type for define the top element. Okay. So you can here and check the last element of the stack using this stack decrement 1, and this give us the top element without modifying the stack itself. Okay. So now just to save this code again and just click on in this the run button. So as you can see here, the top element of the stack is 13. That's just perfectly done, and see the expected output. Okay. And next topic here I'm create the also another example. And now here I'm creating the checking if the stack is empty. And you can see here I'm just add a function to check if the stack is empty and the pop elements until the stack is cleared. Okay. So you can see here I'm already initialized for the 3 elements. And next step here and create the function to check if the stack is empty. So you can see here on type of the def is underscore. This is a empty, and this inside I'm include for is a stack. Okay. And then going to the next line, and here I'm use for the return statement and define for here the length of object is a stack and is equal to 0. And next time add the pop all elements. So we here I'm just type for is a while, and then type for the not for is underscore. This is the empty, and this inside I'm include for is a stack, and also going and run type for this tag dot apply in the pop method. Okay. And just use the spring function and this inside and create here it's a current the stack, and then I am properly define the symbol of a stack. Okay. And here I am also just check if the stack is empty, so you can see type the print function, and here type is perfectly is the stack. Okay. For the empty. Okay, you can understanding. And then I'm just calling for the variables method for the empty stack. Okay, that's perfect. That means here I first of all define the function is a empty stack that check if the stack is empty by checking the length of the list. And then here I use a while loop to pop elements from the stack one by one until it's empty. Okay. So you can see here the properly create this code, and now just perfectly save this in all code and just click on in this the run buttons. Okay. So as you can see here, first is the current stack is at 10, 20. Then current stack again for the 10. And the current stack is empty because it's print the stack empty is perfectly true. That's what's perfectly done. Okay. So that's it for the today's tutorial for implemented a basic stack using list in Python and explored push, pop, pick, and the empty check operation. So stack are essential in various algorithms and the real world applications. Okay. So mastering them is important. So thanks for watching and happy coding. Okay. Hello everyone and welcome back to today's another tutorial topic. So today I'm defining for the applications of stack in Python programming. So here I'm explore for how stack are used in real-time scenarios such as backtracking and the browser history management. Okay. So now let's also work through the here I'm provide for the best example and explaining the code and output. Okay. So first of all here I'm explain for of the stack. So a stack is a linear data structure that follows the last in first out principle. This means the last item ordered in, the first on to be removed. So some real world applications of stack include under functionality in editor, browser history, and the backtracking algorithms. Okay. So first of all here, I will put an example of application on the browser history. So in this stack can manage the browser history allowing user to navigate back and the forward. Okay. So now let's begin. So you can see first of all here I create the class just browser history. So can this properly type is a browser then story and here I'm looking for this flow. And then here I create the function save and double dash and also type for here it's a is init and just going the next line and here I'm create a stack to store the visited URLs. So just type for the self dot create the story. Okay, and then is equal to use for the specified and wrap. Next time again type the self dot is the use for the forward. So you can understand the forward is a step. Okay, and is equal to again use for that is step to store the forward URLs. Okay. And next time create for the another function is date and then type for this properly is the visit underscore this entire include for this the URL. Okay. And then going to the next line of code, the first of all here I'm type for self dot this type of the story is equal to sorry it's not equal dot use for in this the append is the add for the URL. And next time we give create for the self dot is type for the forward stack dot apply in this the clear this method. That is the clear forward story on the new page. Okay. And instead use for in this another print function. So first of all we are creating a formatted output. So define for is a visit date and create row and include for in the simple of row. That's it perfectly great now. So here I'm create these are double quotations inside. So just remove this one. Okay. It's a perfect fit. And next let's check here and create the another function. So now we get this and then type for it's the value. And just going the next line of code and here and use for the if statement. And also created the length of object and include for the properly self dot increase the story. And now create for the data for one. Okay. And first of all, here I'm type for the last underscore the page and is equal to type for the self dot define the story dot apply this option. Next time again type for here is a self dot apply for here the forward stack and again use for this append method and include the properly the last page. Okay. And next use the string function and here first of all I'm type for it's a back to. Okay. You can see here that is a back to and create define the self dot define is a story and here I use for the empty square the square brackets include the decrement one. Okay, and next time create for 18 brackets log and just going and here I'm type for the another print function. So here I'm type for the another method or no more story. Okay, so you can understanding is created properly and then I'm apply for here is a forward. So first of all here I am copy for in this code. Okay, so just I'm copy and paste for here the next line and create another function and just change one. So first of all here I'm create the back and now create the forward function. So you can see here I'm type the forward and use for the cell if statement and then remove for is the length, and here I'm apply for is a perfectly self dot use for here is a forward step. And now create for here is a next phase. So we can understanding the next phase is equal to, so here I'm defining for the self dot stack for is a forward stack dot apply in the pop method. Okay. And now for the self dot use for is perfectly. So just remove for in this code. So first of all, we have type the self dot use story dot apply in the append, and also this inner and include for here is the next phrase. And now just created for here is a string formatted output. So just type for is a forward to define it properly. This is the next phrase. Okay. And instant here is a no forward phrase. So you can see remove and then properly type is a forward English. Okay. You can see here defined is perfectly in this function, and now just use for the user's example. So you can see just click the next space, and first of all here typer is a browser. If the browser is equal to new typer in this browser story in this method. And next time we can create the browser dot type for the visit, and here I'm just define for this randomly create the Google dot com. Okay. And next time create begin the browser dot just visit here the another URL. So here type for this stack overfollow.com. Okay. So stack then overfollow.com. And also here in create, just type for the browser dot apply in the back method, and again define the browser dot apply in the forward method. Okay. That means it's completely creating the example, and here you can see first of all here I'm create the browser history class and the two stack on for the visited history and another for the forward page. And when it's visiting here the new URL, the forward stack is cleared, and you can see here first of all, I'm creating this the back method of the last visited page from the story stack and move pins to the forward stack. And also creating the forward method is just type phrase from the forward stack and add them back to the history. Okay. So you can understanding in this example, and now just properly set this code and just click on in this the run buttons, and let's see the outputs. As you can see here, first is print visited google.com and the visited for the stack overfollow.com back to google.com and the stack over.com. That means in this the visited google.com and the stack overfollow.com. When is go back the last visited page is removed from the story and add it to the forward stack and using the forward function and return to the previous page. Okay, so you can understanding this properly in this example. And now just going to another example for the applications for the backtracking. So here I'm create the major solver. The backtracking word stack helps us find the solution to problems like solving a measure. Okay, so you can see here I'm create for another example. So just going for this the first one here and create the function. So now just I'm remove for this the all code. Okay. So here first of all I'm defined for the function name is a solve underscore this my job. So I'm magic and this inside I am just gonna for me magic type for the start, and also here I'm type for this the okay. And now, first of all, here I'm type for is the is a stack SEA stack is equal to, and here I include for this start that's means the stack to hold the path. And then I type for here is the visited is equal to type this visited in the state this method. Okay. And now here I'm create for the y the stack. So you can understand here I'm use for the y and then type is properly stack. And just going the next line, and here I'm use for this case date current underscore the post is equal to type of properly this big primitive in this stack. And also here create for if statement and then type of the current pops is equal to for input the in. And now we use the return statement and then type for this properly this stack that should return the path when the end is the list. Okay. And so here is not simple is the only the flow. And then use for the properly. So first one check the y stack, then current and if the current and the pause, okay, is broken. And next step here, I'm free for, okay, so just going the next line. And then here I'm type for it perfectly is a stack dot used in this the pop this method. Okay, so you can understand it. Use the pop method and then going and then type for here is a visited dot applied into the add and this things that I'm include for is a current underscore in the post. Okay. So you can understanding and now I'm defining for the another function. So is create that and now just going for and here and use for the magic example for 0 is a valid part for a is a val. So you can see here I'm type for is a magic and is equal to use for the square bracket inside and include for here the first use is 1 and type for the 0. First time type the 0, 1 and 0 and again 0. And next time create another square brackets with the same type of the 0, 0, 1 and 0 and 1. Okay. And again create it. So you can see here I'm first of all type 0, 0, 0 and 1. And in written for the another square bracket so person type 1, 1 and 0, 0. That's this perfectly great and just going the next line of code. So you can see here, first of all, I'm used for the start. So just I'm type for is a you can see it's the start and is equal to define for this parenthesis is 0 and 0. And next time use for the end point. So if the E and V is equal to the end point create for the G and the G. And it's not now. Only uses parenthesis for G and G. And also here we define for the symbol of the path is equal to. So here I'm type for is the solve underscore this measure and this include here the magic and also use for is the start method and also thread is the ending point. Okay. And now we use for the print function and this thing that I'm include property. Here I'm type for the path to exist and declare for this method of path. Okay. That means is properly using for the magic solving algorithms and the stack is hold the current path. And you can see here I'm creating the backtrack by popping position of the stack if no valid measure are available. And you can see here is also created for is valid move this method. The is this function just check if the next move in the within bounds on a valid path. Okay. So you can understanding in this example and now just I am properly saving this all code and just I'm click on indicate the run buttons. Okay. So here just I'm saving this all code. Okay. And just let me run this code now. Okay, so as you can see here, it is perfectly clean for the output, for the path to exist, for the 3 and 3. That's what is perfectly done in this today's tutorial topic and here I'm properly great now. So just to properly explore for here is the two practical applications of the stack, managing the browser history and the solving a match and with the backtracking. So this example is demonstrated for how useful stack can be in various programming scenarios. Okay, so try this concept in your own project. Okay, so now just thanks for watching and happy coding. Okay, hello everyone and welcome back to today's another tutorial topic. So today I'm creating here the queue in Python. So queue are an essential data structure that store element in a specific order for retrieval. So here just follow the different principle of ordering such as FIFO, the first in, first out, and the priority based retrieval. So in this session I properly explain for the introduction to queue and the type of like the FIFO and the priority queue. Okay. So you can see first of all I explain for what is a queue. So a queue is a linear data structure where elements are added at on, end, rear, and then removed from the other form. And the idea is similar to waiting in a line. The first person in the line gets the serve first, while a new arrives to join the end of the line. And next time also explain for the type of queue. So the type of queue is a two type. First one the FIFO, like the first in and the first out, and next the priority queue. And here I explain for the first in and the first out. So this is the simplest type of the queue where the first element added is the first on removed, like standing in a line for service. And so for example, this use case the task scheduling, where tasks are executed in the order they are received. And next time explain for the another type of the queue like the priority queue. In this type, each element is assigned a priority and the element with the highest priority is served first regardless of its position in the queue. And here I use the example for just job scheduling in the operating system, where is high priority task and executed before the low priority ones. Okay. So here I provide for the example for the FIFO the queue in the Python. Let's provide a simple way to implement a FIFO queue using the queue class. So now this time open for here is a PyCharm in the code editor. And now first of all here I'm import for in the simple of queue. Okay. And now create here is a FIFO queue. So first of all here I'm type the FIFO underscore this is a queue and EUE is the perfect and is equal to declared in this queue dot is properly defined for in the queue this method. Okay. And now adding the elements in the queue. So first of all I'm type for the FIFO underscore this queue and use for the food because it's add. So here I'm use for the alphabet character of it. Okay. And now just I am copy for in this line of code and with the next two lines. And change and just change alphabet character next to B and here is a C. Okay, is a perfect. And next step here, I'm just removing the elements from the queue, the FIFO order. So you can see here I'm typing the print function and this inside I'm include for the FIFO queue dot apply in the get this method. Okay. So you can understand it show the output for the alphabet character of it. Okay. And you still copy for this line and then paste for here is the next two line. Okay. So you can understand and properly use it. So these elements are added in the order for A, B, and C and are removed in the same order. Okay. So now this I'm saving this small code and just click on release the ground buttons. Okay. So as you can see here is a perfectly clear for the output for A, B, and the C. Okay. And next topic here I'm also creating is a priority queue in the pipe. So for a priority key can use the priority queue class from the queue module and this structure is element is associated with priority now. So you can see here I'm just removing this the all code. And first of all here I will create the priority key. So just type for is a priority underscore this is a queue UEUE and is equal to first of all define this queue and also here I'm type for is perfectly this is a priority queue. And next I'm adding the elements with a priority for the lower number, in this case the higher priority. And then and now just run the next line of code and first of all here I am type for is a priority queue dot apply into the put method. And this inside including in this parenthesis, the first one is the number is 1. And then here I'm type for is a low priority task. Okay. So you can see here I'm properly typed it below, then the priority, this is a task. Okay. Here is a perfectly correct, and now just I am copy for in this line of code and then paste for here to the next line. Okay. So you can see here I'm changed for this is a. So here I'm type for is a high priority, and then here I'm use for the medium priority. Okay. So you can see here I'm type the medium with a high for 0 and the medium for say 2. Okay. So here is a perfect fit, and now just I am removing for the element for based on the priority. So just go in here and then type the print function, and this inside I include the priority dot apply this the get this name. Okay. So same for the high priority task, and now just I am copying this line of code and paste for here to the next code. Okay. So you can understanding, and here I'm create for in this the each element is a tuple where the first value indicates the priority, the lower value indicates the higher priority, and the element are remove the order of the priority. Okay, so you can understand perfectly. And now just I'm saving this all for, and just click on in this the run buttons. Okay, so as you can see here is the perfectly finished. First is the print the 0 means the high priority task, cons means the low priority task, and the 2 means for the medium priority task. Okay, that's what is perfectly done the student's tutor, and here I'm properly defined for the introduce to give you the queue of the display the two common types, the people queue and the priority queue. And so for how implement is Python using the queue module, and explore for here is a real world case where each queue type might be useful. Okay, so that's all for the students tutor. So thanks for watching and happy coding. Okay. Hello everyone, and welcome back to today's another tutorial topic. So today I'm creating here an implement for the queue using the two different approaches in the Python, the list and the dequeue. So now first of all here I'm explaining for the data introduction to the list and the queue. So it's a different approach in Python for the class from the collections module, and both are common methods to create queue, but they differ in the terms of the performance and the ease of use. Okay. So you can see here, first of all, I'm implementing a queue using the list. Okay. So although the Python list can be used to implement queue, they are not the most efficient for queue operations. Removing the first element from a list requires shifting all other elements loading to a time the complexity of output for n. Okay, so here I'm used for the best example. So first of all, here I'm implementing a simple people queue using a list. Okay, so first of all, here I'm just have import for is a queue. Okay, and now first of all, here I'm type is a. So you can see here I'm use the QUEE. So Q underscore in this the list is equal to define for the proper entry. So entry point. And now create here is the enqueue operations for adding elements to the queue. So first of all here I'm type the queue list dot apply in this the append, and this inside I'm include for the character of a. Okay. And next time again create for the queue list dot use for the append method, and here I'm include for the character of b. And next time again created this queue list dot apply into the append, and here I'm include for the alphabet character of c. That's which is perfectly done. And now I'm create here is a dequeue operations removing elements in FIFO order. So you can see first of all that the print function, and here I'm include the queue list dot apply into the pop method for the 0. again uses this one and then type for is a QList dot indeed the pop method and define for the 0. And again this lastly use for declare indeed the QList use for the pop method and its perfect done. You can see here I'm first use for the enqueue is defined for the append method to add the elements to the end of the list. And we can see here also the pop method for the 0 and remove the elements from the list, but this operation has a time for the complexity of the 0n and because all elements are shifted on position to the left. Okay. So you can understand perfectly great, and now just I'm saving this all code and just click on in the run buttons. Okay. So now as you can see here is a properly print the output for A, B and the C. Okay. You can see here it is perfectly creating now for the queue list. Okay. Next topic here I'm implementing a queue using the DQ. So the DQ for the double-ended queue from the Python collections module in design for first appends of and the pops from both end and the time complexity for adding and removing elements from the font and the back of a DQ for the 0 and 1. It's making it much more efficient for queue operations compared to the list. And you can see here I'm used for the another example for people queue using first in the first out queue using the DQ. Okay. So you can see first of all I'm just going here and just remove for in this the all code. Okay. So first of all here I'm type for is a from, then type for is a collection. So you can see the collections and import for here is a DQ. Okay. And now I'm creating DQ object to implement a queue. So first of all here I'm type for is a queue underscore is a DQ. Okay. And is equal to define for in this the DQ this method. And now I create here is the enqueue operations for adding elements to the queue. So you can see first time type the queue DQ dot apply this append, and here I'm include for the another character for here I'm type for is a. So define for x, and secondly again created this Q and DQ dot apply in this the append, and this inside I'm include for the y, and also created now just use this append, and here and include for the is judge. Okay, sorry, is judge that was perfectly create now. And the next line here I'll create the DQ operation for removing elements in the first out order. So you can see here I'm type the print function. This inside I'm include for the q DQ dot is type for here is a pop left. Okay. And then just again use and then define this q dot use the pop left, and next time create the j. So define for again. Okay. And also type for this is a pop left. That's which is perfectly creating this example. And you can see here the enqueue for the append. It's similar to the list for append method, just add element to the end of the DQ. And in this the DQ for the pop left this efficiently remove and return the first element in output for the complexity is 1. Okay, so that's it for the today's tutorial, and now just save this code and also click on indeed the run buttons. Okay, so as you can see here it perfectly print the output for x, y and z. Okay, so you can see here is completely done the today's tutorial, and here I am properly implementing for queue using the both Python list and the GQ class. Okay. So I hope you proper understanding this previous tutorial. So now thanks for watching and happy coding. Okay. Hi everyone, and welcome back to today's Python programming session. And today just we're going to learn how to use for loops and the range function effectively in Python. So these tools are essential when you want to repeat actors in your code. So now let's get started. And first understanding what are for loops and the range. First of all, a for loop is used to iterate over a sequence like a list, tuple, string, or a range of numbers. And here, the range function is especially useful for generate a sequence of numbers. To loop through, it can take on 2 or 3 arguments like a start, a stop, and a step. Okay? So today first using the basic loop example using the range. So now normally just open the for loop and declare I variable, and including here is currently the range is inside the value of 5. Okay, so now here using the print function, and this inside is type the sample message like this hello and the variable of I. So here you can see just print this example, and here in this hello is printed the 5 times along with numbers from 0 to 4. And when you give in this the range on its argument is start by 0 by default. Okay, so save this code, and now here is properly print output for hello is 5, 10, 3. Okay, so I hope you're understanding this example. And then next you also use this another different example working for looping with start and with and stop. So now again use the for loop I variable in the range and this inside including the first value is 2 and the second part is 7. And now use the print function in the I variable. So here in this example the loop is start at 2 and stop before 7. And the output will be printed here. So just click on and just going here, and as you can see here the output printed for the 2, 3, 4, 5 and the 6. Okay. So here this output is correctly printed. And you can try, here is another example for using step in range. Okay. So you can see in this inside this value change and first apply is 1. Secondly use 10, then 2. Okay, so here in this example, this is step value of 2 and the loop prints every second number for 1, then 3, then 5, then 7, and then 9 is great for looping interval. So now let's see here the output. So as you can see here is the correctly print output for 1, 3, 5, 7, and then 9. Okay, so here's a simple example is completely done. And now here using for another different example for looping through a list. Okay, so let's today first of all here they declare the variables if the fruits is equal to using this square brackets inside apply the fruits name first using the apple. Secondly including the fruits it's called the banana. Then inside the fruits is a cherry. Okay, and then use for the for loop like this the fruit in the fruits. Okay, and then just clone and give them the print function, and today first printed here the fruits variable. So here you can see the for loops aren't limited to number, and here in this loop throw a list of the fruits and print each one. So now here again save this code and just run this code now. So as you can see here, the output is printed for the apple, banana, and the cherry is correctly printed. Okay. So here is a completely done in this simple example, and I hope it's clear and understanding. And then now also using the another example for the nested for loops with range. Okay. So today first apply the for I in the range, and this inserted the value is 1, 4. Then again use the for loop, the variable of j, in again type this range, and this inside of the same value. Okay. And now also using here the print function, first declare the I variable, and then single quotations inside using this multiplication sign, and the variable of a, then in the sense that including this equal sign, and then now apply I and the multiplication of the j variable. So here, in this nested loop creates a mini multiplication table from 1 to 3, and the outer loop runs for each row, and the inner loop calculates its product. Okay. So now saving this code again and just click this run icon, and as you can see here, see the output here, the perfectly printed. You can see is 1 into 1, 1 into 2, 1 into 3, 3 into 1, 2 into 2, and here is the last 3 into 3 is 9 is perfectly printed. Okay. So now here is a pretty simple calculator and is all this product. So now it's completely running. The student and tutor is correctly working with all rules, help with repeat action, and the range function gives you control over the stack, the stub, and the state of number sequence. Okay. So thank you for watching and keep coding with Python. Okay. So happy coding. Hi everyone and welcome back to today's another tutorial topic. So today I'm properly implementing here the linked list. Okay. So now let's get started. So first of all, I'm explaining for the linked list. Okay. So a linked list is a data structure that consists of a sequence of elements where each element points to the next on in the list in Python. And here I'm going to typically implement the linked list using the classes. So first of all, here I'm explaining for the basic component of a linked list for the node and the linked list. So node for each element of the linked list is a node containing the data and a reference or a pointer to the next node. And the linked list, so the linked list itself is a collection of nodes where the first node is a head and the subsequent node are the linked via their point. So here I'll create a simple implementation of the linked list in Python. Okay. So now let's get started. So first of all, I am opening this code editor. So you can see here I am properly defined for the class like the node. Okay, and then I am apply for the function and type for the init. So here I'm defined for the another attribute like the data. So next I'm use for here the self dot define this data is equal to type for again this data. Now type for the self dot apply the next node is equal to this is a node. Okay, and now I'm here create the linked list class. So you can understanding create a class and the class name like it. So linked then list. The list and going the next one and here and to find for the function for init and here I'm type for the properly self dot is defined in the head this method with properly given node. That means here I'm only initialize the head node as a node. Okay. And next I'm define for the method to append a new node at the end. So you can see here I'm talking another function name is a append and this interim include first itself and again define for this data. Now I'm create here is a properly the new node is equal to declare properly this node and this node inside I'm include for the data. And now I'm use for the if statement and then type for the self dot apply into the head method for is a none. Okay, so you can understand and in this line it means if the list is empty to set the new node as the head. Okay. And also here I'm just define for is a, so is the none. It's not node, it's a none. And sorry, I'm just remove here and create this clone. And first of all here I'm define for the properly self dot apply in the head is equal to create here is a new node. And now I'm perfectly uses for here the return statement. Okay. So you can understanding the perfectly create. And now here I'm also defined for the traverse to the last node. Okay, so first of all, here I'm type for the last underscore. This is a node. So you can see here I'm create for the space. Okay, and also going for here is the last node is equal to declare properly the self dot is used for in this the head method. And now properly use a while statement and then type for the last node dot apply in the next node. Okay, and the fine is properly I again add the last node is equal to create the last node dot apply in the next. And you can see here and create the last node dot apply in the next and is equal to define for the perfectly in the new node, because in this line is create link the last node to the new node. Okay, is done. And next step here I'm create for the another function, and here I'm creating for the method to insert a new node at the beginning. Okay, you can see here for another function is the prepaint. So PPNP. This one is a perfect, and then type for again is it include the data. And now here first is type the new node. So you can understand it. It's a new. This is a node and is equal to type for again this node inside include for this data. Okay. And now I first is declare the new node dot apply in this the next node is for the define for the self dot apply in this the page name. So that means here I am link the new node to the current head. Okay. So you can see I'm type for the self dot apply the head is equal to declare here it's a new node. That means it's update for the head to the new node. Okay. And next step here and use the method to the display the linked list. Okay. So you can also here define for the another function name is a display. Okay. And then going the next step, and here I'm type for it's a current node is equal to define for the self dot apply in the head method. And again use the while and create this current, then apply for the print statement. And in this inside I include for the current dot this is a data, and also here create for the end is equal to. So now I create this double quotations inside include for the arrow sign. Okay. And next step here I'm type for is the current is equal to again type this current dot apply this is a next is a next node. So is almost done in this code, and now here I'm perfectly apply the print statement, and this inside and include for here is a non this node. Okay, it's almost for is a perfect. And next step here I'm create for the another function here. Just create now. So you can see here I'm create the method to delete a node by the value. We can see here I'm have the another function name is a delete. So DE then LETE, this delete node include for the self, and also here I'm include for the key. Okay, and apply for in this the current method is the current node is equal to declare for the self dot apply in this the head method. Okay, so you can see here the perfectly created now, and use the if the head node itself or holds the key to be deleted. Okay. So you can see here I'm type for the if and then type for the current node and use for again the current node dot apply this the data, and double is equal to declare for in this the key and then clone. First of all here I'm type with the self dot apply in this the head is equal to again create this current node dot apply in this the next node. It's the update here. And again create the current dot is equal to type for the none because it's free the old page. Okay. And now lastly apply this return statement. Okay, so here my code is almost done, and now the next step here I am created just now use for search for the key to be deleted. So you can see just going the next line of code, and you can see here I'm type for is a PREZ and is equal to type for this is a norm. Okay. And now I'm again applying this the while statement and then include for here the current and apply for the and statement and then type for the current data, then use for the not is equal to is equal to declare in this key. Okay. And now I create for here is a pre is equal to is a current, then again type for the current is equal to that the current dot the next node. Okay. You can understanding, and here I'm also created if the key was not present in the linked list. So here I'm used for the properly if statement and calling the current is the norm. Okay. And now I'm used for only the return statement. And also here I'm create the unlink the node from the linked list. So prevent, then apply the next node. Okay. And is equal to apply for here is the current the next node with the linked list, and then apply again the current is equal to this is a norm. Okay. So you can understanding, and here I'm again create for the method to traverse the linked list. Okay. So you can understanding, and here I'm defined as perfectly the functions. It's like the diff, and then type for is a reverse this one, and then going the next line of code, and here I'm used for the prevent is equal to type for this is a norm. Okay. And now I'm create for here is a this is a current method is equal to type for the self dot apply here is a head method. Okay. And again use for the while statement and then create this current method and use for the next node. So you can see and this type for is a next underscore this is a is a node is equal to apply for the current dot this is the next. Okay. It is stored the next node and again calling for the current dot the next node is the next and is equal to defined for here is a prevent. That means here is reverse the current node the pointer, and also here type for is a prevent and is equal to declare this is a current. That means here I'm just move the prevent and the current on step the forward. And again define for the current method is equal to type for is the next node. It's done. And now define for the self. You can understanding for the self dot apply in the head method is equal to this is a prevent. That means here I'm update the head to the new first node. Okay. And now I'm just going the next line of code, and first of all here I'm proper uses the example. So you can see here I have the if statement and double dash and then type for here is name and and again use this double dash is equal to. So first of all here I'm this double quotations this inside I'm include here is a main method. Okay. And now just create this clone, and also in the next line and here I'm declare is properly. You can understanding the link underscore this is a list is equal to properly declare this is a linked list. Okay. So you can understanding, and now I'm apply for is the append element. So you can understand that for the linked list dot apply in this the append method for number is 1. Okay. And secondly, and again create this linked list dot apply into the append and this include for the number of 2. And lastly, use for and apply this append and then use for the 3. That means is completely create now in this example, and here. So here is a completely done and properly created in this the linked list. And you can see here I'm first of all create for the node. So is the first I'm used for in this the append this function just add a new node with the given data at the end of the list. And next time create for here the prevent. So it is add a new node with the given data at the start of the list. And also here I'm creating for in the display function just print the data into the linked list from the head to the node at the end. And next time also create for the delete function, just delete the first node with a specified value like it. And also here I'm create for in this the reverse. So this reverse function, the linked list in a place. That's what is properly implementation in this simple singly linked list with the basic operations such as this code. Okay, so you can see here I'm just created for the linked list for and after prepending, then after deleting and the reversed list. Okay, so you can understand it. And now just I'm properly save in this all code and just click on in this the run buttons. Okay, so you can see here is a perfectly see the results. So just I'm going for, and you can see here it is the original list, then link after prepending, and here the list after deleting. Okay, so I hope you proper understanding in this example and perfectly working and implementing the simple. So that is perfectly done. Is they properly implement the linked list in the Python programming. Okay. So now just thanks for watching and happy coding. Okay. Everyone and welcome back to today's another tutorial topic. So today I'm implementing here the use case and application of the linked list. Okay. So now let's get started. So first of all, I'm explaining for the linked list. Okay. So here I'll properly discuss the use case and applications of linked list in Python programming. So linked lists are the fundamental data structure used in various scenarios. So today I'm explore for the example, and here I'm use the real world example. So now let's get started. So you can see here I'm properly defined for the linked list and use the use case of example for the dynamic memory allocation. So now here I'm properly used for the linked list. Okay. So you can see the linked lists are often used when the size of the data structure needs to change is dynamically. Okay. So you can see here, first of all, I am create the class. And create the class and the class name defined for the properly is a node. Okay. And now I'm defined for the function and then double dash, then type for the init. And here I'm defined for the another attribute like the data. Okay. And then first of all, here I'm type of the self dot is defined the simple the data is equal to again type this data. And next time again create the self dot apply in this the next node is equal to declare it's a node. Okay, that's perfect. And now here I create for the another class name like a linked list. Okay. So you can see here I'm properly typed it's called the linked list and define for the function is def and use for the double dash for the init and then just going here and then type for the self dot define for is the head is equal to declare this is a node. Okay, that's which is perfectly clear now. And next step here I'm use for the append method. So first I'm type the def the function and also here I'm type for is a append and then self just type for again the data and next step here I'm create the new node. Okay. So you can understanding the new node is equal to declare for this node and this node is inside and include for the data. And now I'm use for the if statement for if not then type for the self dot apply in this the head and then here I'm use for properly the self dot the head method and is equal to declare here it's a new node. Okay. And next step here I'm use for the else statement and then type for is a temp. So is a temperature is a temporary and then use the self dot in this the head this method. Okay. And next step here I'm just use again. So we can see I'm just apply for again the while statement and then type for is a temp dot apply the next node. Now when define this properly again, the temperature is equal to type for again the temp dot use the next. Okay. And now I'm again type for is the temp dot apply in this the next is equal to here and properly defined is the new node. Okay. It's almost perfectly done, and now here I'm create the another function like first we have the def, and here I'm method name create here the display, and this inside I'm include for the self. And first of all here I'm type for is the current and is equal to define for the self dot apply in the head method, and again use for now the while statement and declare in this the current method. And now I'm use for here the print statement, and this inside I will include for the current dot the data. Okay. And also here I'm use for in this the end is equal to. So you can see first of all I am create here the double quotations, and in this inside I will include for the arrow sign. Okay. And next time create for define the current method is equal to again define this current dot apply in this the next node. Okay. And now I'm properly create the another print function, and this inside I will include for here is a none of the node. Okay. So you can see here is a properly create almost my code, and now I'm use for this example is properly. And you can see here, first of all, I am type for is a linked list and is equal to define is perfectly the class name is a linked list is empty here. And now just type the linked list dot apply in this the append this method. So here I'm include for the node is a 10. Okay. Next time again create the linked list dot apply in this the append method. So here I'm include for the 30. And again created this linked list dot apply in this append this method. So here I'm include for is a 50. So here almost my code is completely done, and here I'm properly defined for the method is the display. Okay. That means is properly create now this example, and you can see here and apply for is a dynamically adding the nodes to the linked list as a needed. And its need is contain data and the reference to the next node, and this demonstrate for the linked list are the ideal for the dynamic memory allocations. Okay. So you can see here the properly create in this my all code, and now just I am perfectly saved in this all code, and just I'm click on in this the run buttons. Okay. So now just wait, and as you can see here, they perfectly see the result and printed the proper node. You can see here is a 10, 13, 15. You can see the dynamic memory allocation where the elements can be added or the removed without for here is a reorganizing the entire structure. Okay. So I hope you proper understanding this to this tutorial, and here I'm properly use the applications of the linked list. Okay. So now just thanks for watching and happy coding. Okay. Hello everyone and welcome back to today's another tutorial topic. So today I am creating the example for the three essential for the tree structure in Python. So first one the binary tree, then binary search tree and the AVL trees. So here I'm use and see for how is implemented and compare their feature and use for the simple example. Okay. So first of all, here I'm create example for the binary tree implementation. So now let's start with the basic binary tree where its node can have up to the 2 children. Okay. So you can see here, first of all, I am create here a simple class, so class name like a node. Okay. And then here define for the function is this, and then type of double dash for indeed the image. Okay. So here I'm define for the attribute, so like a value. Okay. And then here I'm use for is a self dot apply for indeed the simple value is equal to again define this value. And next time type for here is self dot is type for the left tree and is equal to define false because it's a not. And second time type for again the self dot and create now is a right tree is equal to again create this not. That was perfect. And now here I'm create a binary tree. So you can say first of all I'm type the root is equal to define for this is a node and this insert and include for the node is 10. And again type for the root dot apply in the left tree is equal to first of all type the node and define for the value is a 5. Okay. And also create again define for into the root of the node and then type for the right node is define for the node and include for here the 11 is it 15. That will be perfectly great. So here I'm used for the parenthesis. Okay, it's perfect now. And now here I'm used for the proper in the print function. So first of all here I print for the root node. So you can see just type for the root dot define for the symbol of value. Okay. And again in this print function, so in this inter I'm include for the left child of the root. So first of all I'm define for the root dot apply the left child and define for the properly in this value. And again uses so just define for the root dot apply in this the right node then define this value. Okay. And if screen for here is a right child of the node. That means here I properly define a node class that initialize the node with a value. And the left child and the right child were then manually create a binary tree within the root node 10, a left child 5 and the right child for here is a 15. Okay. So you can understand in this example 4 and now just time just see the result. So you can see here perfectly print output for 10. It's a root node 5 for here is the left child and the 15 for is the right child. Okay, so I hope you understand it. It's done for this example. And its topic here is another tree like a binary search tree. So here I'm just implementing a binary search tree. If the ST4 is node values in the left subtree are the less than the node's value and the value in the right subtree are the greater. Okay. So you can see first of all I'm create the another class. So just I am remove for in this code. Okay, so you can see just remove for in this code. First of all here I'm create the class name like a BST and then the next step here I'm type for the function div and then double dash and then type for this init and this inside I'm going to next line of code and here I'm only use for the self dot use for properly in this the root node is equal to type for is a node. Okay. And now if you for the another function like the div and just type for here the insert and then in this inside I'm include for here the value. Okay. And now I'm used for the if statement. So first of all I'm type for the self dot type the root is the node. Okay. And then here I'm used for again the self dot define the root is equal to now I'm declared the node. So you can see I'm type properly the node and then in this inside I include for increase the value. Okay. And now properly use for the else statement and then type for again this self dot is type for is double is dash for here is a insert. So you can see here I'm type for is perfectly in this dash and just type for in this insert and this insert includes so first of all that the self dot into the root node and also here I'm type for in this the value. Okay. So you can understand. And now just I'm going for again. So first of all here define for again this function this div and declare in this the w dash for is a insert. So you can understand it. This is the insert this node and in this insert first of all define the self dot use the current node and also created here in the symbol of value. Okay. And now we'll use for if statement. So first we'll declare the value is less than here the current dot declare this value. Okay. So you can understand it perfectly and just run the next line of code. So here I'm making use the if statement, declare the current value dot is type for here is a left node is a node. Okay. And then create again this one and just type for is a current node dot apply in this the left, so you can understanding the left is equal to properly define the node and in this input input or this value. Okay, and now you use for the else statement and just here in the next system here type for, so you can understand and just copy for in the cell dot insert and just I am first is create the left node and here I'm insert for the right node. So you can see just copy for in this code and paste for here. In this the next line I'll just change for is the cell dot insert and then here I'm include for first of all let the current dot apply in this the right node. Okay. So here is the perfectly correct and now this create a binary search tree. So first of all, I'm just doing the next line of code and define for is a BST. So just I'm removing this code and properly here I'm applying is a BST and is equal to again type for this BST. Okay. And this will the next line of code and first of all type is a BST dot apply in the insert and then include for the value is a 20. And just again type for the BST dot apply in the insert method and here include for the 25. This note and again use for the BST dot apply in the insert and include for the 30. That's this is perfectly done. And just I'm going for in this insert for first and print for the root node. So you can see here I'm defined for is the first the BST dot use for the root node. And also here I'm defined for is the symbol of the value. Okay, so you can understand. And now you create for again the BST. So add for the BST dot apply for the root the left value and again just going here. And then type for the BST dot use for the root the right value. That means here I'm properly build a BST with the insert function. And in this the underscore in the insert function help us place the value in the appropriate position based on the comparison with the current node. Okay. So now I am just properly saving this all code. So just I am select all and save this code and just and click on in the run button and let's see the output. So you can see here is a 25 line. I am pitch for the simple error. So you can see here I'm defined for the BST. So you can properly create the binary search tree. So BST and define is perfectly just going for here. And you can see I'm just again check for in this code. Okay, so you can see here and previously create for the example for the binary search is adjust for here is binary tree is properly adjust for here to binary search. Then you can see here and again insert for it is the same code because the class node and here is the root node, the root left node and the right node and again use for the another class for the BST means for the binary search tree. It's properly adjust for the binary tree for example. Okay. So now just I am is properly saving this all code and just click on in this the run buttons. Okay. So now let's just properly see the output. So first is the print for the root image is 10 and the left child of 5 and the right child of the root is a 15. Okay. That's which is properly working in this example. And instead of here and create another example. So you can say just remember in this all code. So here I create for the AEL tree. It's a self-balancing binary search tree. Finally, just implement here an ALV tree, which is a self-balancing binary tree, and ALV tree automatically keep the tree balanced after every insertion to ensure the efficient operations. Okay. So you can see here and create for the ALV node and also create it for the example. Okay. So you can see first of all here I'm create for the again the class name this type for here is the AVL in this the node. Okay. And just going the next line of code and here I'm defined for the self and then type for the double dash in this the init. Sorry. And just type for double dash this init. So here I'm defined for again in this the value. Okay. And next here I'm type for the self dot define for its properly the value is equal to in this value. And also here I'm create for the self dot is type for is the left node is equal to is the node. Second time again type for the self dot is type for here is the right node is equal to is again the node. And now again create for the another attribute like the height is equal to for 1. Okay. And now create for the another class. So just type for the class name. It's a AVL tree. So AVL, sorry, in this the tree. Okay. So you can understand. And then here I'm creating it in the continuous state. And then type for is a insert. So this insert I insert for the self and also type for the root and also create it for in this the value. Okay. And next is to then use for the if statement and then type for the root is a non. Okay. And then I create for here it's the return statement. You can see here I'm type the return for AVL. It's a it's not the tree. So here I'm just type for the AVL node. And this inside I include for in this the value. Okay, so here I'm used for the properly in this the again the if statement and type for the value is a greater than just type for the root node. It's the value. Okay, so you can understanding and then I'm doing for and here I'm type for is the root node dot is type for in the left. Okay, left node is equal to type for again the self dot is type the insert and this insert and include for first is include the root node. Okay, so you can understand for type for the root dot in these are type for the left node and also define for in this is simple of that. So now I'm making use for here is else statement and type for again the root dot use the right node is equal to type for the self dot is used for the insert methods in this insert and include the root dot apply in the right node and also print it in the value. Okay, so you can understanding in this code is almost created now. And now just I am defining for here is going in this the so just I'm create now. So first of all here I'm use for the height. Okay, so now let's try. Sorry, I'm just going the next line of code and here I'm defining for is a root. Root dot apply in this the height is equal to 1 and the class operator. So it's not correct. So first of all, properly define in this the root. Okay? And now use for the class operator and define for the maximum value. So you can say first of all I'm having this inside and create the self dot apply in this the get. So just type for the get underscore in this the height. So height and in this inside I'm properly include so first of all I'm type for the root node dot use for the left node. Okay, and again here I'm type for the self dot use for here is a get underscore in this the height. Okay, and this create the parenthesis so you can see here I'm create this parenthesis inside include for the root node. Then apply for here, it's the right node. That's what is properly create now and here I'm also defining this the balance. Okay, so let's type the balance is equal to, so properly type the self dot apply in this the get and underscore in this the balance, and this inside I'm include for the properly in this row. Okay. So you can see here is a completely create my code. I'm just going the next line of code, and here I'm defining for in this the create a ABL tree and the insert element. So you can see first of all here I'm typing for ABL underscore in this the tree is equal to properly defined for in this the ABL tree is function. Okay. And next time use for in this the root is equal to type for is a non. And also here I'm defining for the proper in the values uses. So the square bracket inside of include for the element of 10, 20, 5, then 15, and also here I'm create the 30. Okay, and now you use for here the for loop equal to define is the value in the values. Okay. And next is the theorem used for indeed the root node is equal to type for here is the ABL tree dot is type for the insert, and this insert I will include for the properly first is include the root and second line include for indeed the val. Okay. Now we use for indeed the pre function, so in this insert and type for, so you can see here I'm type the root node after balancing, and then I am calling for in this the root dot this value. Okay. So you can see here I'm properly implement for in the ABL tree, and after is insertion the tree check for the balance, and then and here I'm create is proper. So even here I'm properly create for the ABL tree and properly implementation for after and just implement for here is a insertion, the tree check for the balance and the root node to maintain the balance, ensuring the tree remains for efficient for the operation like searching and the insertion. Okay. So you can see here is properly create in this example, and I'm perfectly create now. So first of all here I'm save for in this all code. Okay. So first of all I'm save this all code and just click on in this the run buttons. Okay. So as you can see here, the perfectly see the result for you can see the root node after balancing for the 10. That's it for the today's tutorial, and here I'm properly explore for the three types of tree in the Python like the binary search tree, and the APL tree. Okay. So now just thanks for watching and happy coding. Okay. Hi everyone, and welcome back to today's another tutorial topic. So today I'm exploring for the three key tree traversal technique like in order, pre-order, and the post-order. So these are used to visit and the process each node in a tree. So now let's see the example, and I hope we proper understanding this technique using the Python code. Okay. So first of all, here I'm creating the example for the in order traversal. So in this, the inner the traversal visit the left subtree first, then the root, and finally the right subtree. So now let's see how it works. Okay. So you can say first of all, I am create in the program is starting create the class node. Okay. So you can understanding the node, and then going for here I'm define for the function for is a double dash for in this the image. Okay. And now I'm create for the another attribute like a value. Okay. And first of all, here I'm type for the self dot define this value and is equal to declare this value. And next time use for here is self dot is declare the left node is equal to is the proper this node. Okay. And now just I'm copy for in this code and paste for the next line, and the strings for in the left tree, and now I'm insert for here is a right tree. Okay. And now I'm creating for the example for use the in order traversal function. You can see type for the date, the function, and here I'm properly defined for the in order, and this inside I include for only the root node. Okay. And then can use for the if statement, and type for is simply increase the root. So, and first of all I'm type for increase the in order. This inside I'm include for the root defined for here is a properly is a left node. And this is the print function. This inside I will include for the root dot in this the value. Okay. And also here use for in the end is equal to only uses for the stable position. Okay. And this same type for in this the in order. And this inside I will include for the root node dot apply in this the right node. Okay, so you can understand. And now I create for the tree. So you can see just going this next line of code. And first of all here, I'm type for the properly in this the root is equal to declare for the node. This include the element of 10. Okay, and now just I'm type for here it's a root dot apply here is the left node is equal to again type for in this the node and include for the value of 5. Okay, so it's perfectly great. And now just I am copying for in this code and paste for here is the next 3 line. Okay, so 1 and then 2 and 3. So first of all here I'm changed and I'm create for it's a right node. I'm just change for the value is a 15. And you can see here I'm just use for the value is a 20. Then I'm apply for here is a left for the left node and declare for the number of element is 2. And create for the left tree dot is type for in this the right tree and declare for the node of this value. Okay. You can understanding perfectly with the pre-order and just to use the spring function and this inside and include for properly in order traversal is a traversal and just doing and use for in this the in order. This include for in this the root node. That's it for example. And here I'm properly define a recursive for in the in order function is traverse the left subtree, process the root node, and then visit the right subtree, and the node are printed in sorted order. Okay, so you can understanding in this simple of code. And now just save this properly and just click on in this the run button. Okay. So as you can see here is a perfectly printed output for the in order traversal for the 2, 5, 7, 10 and the 20 is properly printed out. And next topic here I'm also created for the pre-order traversal. So in the pre-order traversal visit the root node first, then the left subtree and finally just the right subtree. So you can see here first of all I am copying for in order output. Okay. So you can see here I'm copying and then press for here is the next line. So you can see here I'm just fixed. Another simple update. So you can see here I'm used for the pre-order. So it's type for the pre-order node, this root and use for the root dot. So you can see I'm remove for the pre-order in this code. So now first of all the print function, the root, the value and the endpoints. And you can see here I'm type for just remove in the code. And first of all here I'm used for include the pre-order. This include for the root dot apply here is the left node. And again create this pre-order. So you can see use the pre-order this inside and properly include for the root and also here is a right node. That's just the perfectly great now. I'm just doing the next line of code and you can see here I'm copying for again in this code. Okay. So just here use for and then again for the sprint function and here I'm type for properly the pre-order traversal. So you can understand in the pre-order traversal and also created here is a new one. And you can see is under just remove this in order and properly include for here is a pre-order new. So that's it here in this example and create the pre-order function, the process, the root node, the first before recursively visiting the left and the right subtree. And you can see the pre-order is useful for tasks like copying the tree structure. Okay. So now first of all I'm set this in all code and just properly click in this the run button. So as you can see here, it's properly print for the result the pre-order traversal for 10, 5, 2, 7 and 20. It's complete for the pre-order traversal. And next lastly, I'll create for another tree traversal for the post-order traversal. So finally, just explore the post-order traversal. Each weight, the left and the right subtree, and the first the process, the root node, the last. Okay. So you can again and just copy for this code and paste for the next line. So here I'm defined for the another function. So now I'm using for here is the post order traversal. So again here I'm just properly tagged in this the post order with the root node and simply just copy for in this code. Okay. And copy and cut and just paste for this the next line. Okay. So you can see here, first of all, I'm used for, you can see, remove the pre-order and here I include the post-order. And it will just use for remove this pre-order and include for the properly in the post-order. Okay. So the print function is print the root, then value and also for the endpoint. And again doing this last of the code and we can see here, first of all, I'm copying this code, so it's not done, just only print for the print and the pre-order, and then paste the next line of code. And you can see here I'm remove for the pre-order, here I'm include the properly in the post-order traversal. Okay. And again remove and here I'm include for in this the post-order. That's what is completely done in this the traversal into the root node. You can see here in this case, I'm used for the properly in the post order function process the left and the right subtree. And first and then the root node as the post order is useful in scenario like the deleting entry. Okay? So you can properly understanding this example and now just in saving this all code and just click on in these the run buttons. Okay? So as you can see here is a perfectly print output. So first figure is properly print. The post order traversal is 2, 7, 5, 20 and the 10. That means a properly print for the in 3 traversal result. First one the in order, second pre-order and the third the post order traversal result. Okay. So now that's it for the today's tutorial and here I'm properly covered the three traversal technique like in order, pre-order and the post order. So in this technique serve different purpose from searching to the tree construction and the deletion. Okay. So I hope you proper understanding and enjoying in this tutorial. So now just thanks for watching and happy coding. Okay. Hello everyone and welcome back to today's another tutorial topic. So today I'm creating here and explain for the basic of graph theory and the types of the graphs. Okay. So now let's get started. So first of all here I'm explaining for the graph theory. Okay. So graph theory is a branch of discrete mathematics that studies graphs. And a graph is a set of nodes also called the vertices connected by edge. And it is used in many fields such as computer science, biology, social network, etc. So now let's break this down for some basic concept and see how to implement them in Python. Okay. So first of all, I'll explain for the proper the graphs. Graphs means a graph for the triple Z consists of B means for a set of the vertex or loops and the E for a set of each twisted pairs of the vertex. Okay. So here I'm simply explain for the graph theory. And next I'm explain for here the graph theory and the types of the graphs. Okay. So here the type of the graphs here is the most time uses for the undirected and the directed graph. And you can see here I'm create for the almost uses graph type. So first on the unordered undirected graph, directed graph, weighted graph, and unweighted cyclic, the connected graph and the disconnected graph. Okay. So first of all, I explain for here is the undirected graph. That means is edge have no direction because they cannot do nodes is systematically. And the directed graph is means the edge have a direction and the point from one node to another. And the weighted graph is have the associated weights often representing distance, cost, or time. And next time also explain for the unweighted graph for all age have the same weight. Next time also explain for here is a cyclic graph. Contains at least on cycle a path that start and end at the same vertex. And next time also explain for a cyclic graph has no cycle. It's a connected graph. There are paths between every pair of vertex and the disconnected graph for some vertex cannot be reached from others. Okay. So you can understanding with the graph is properly explained for the graph definition and also for the type. So in this session, this tutorial I'm create for the graph representation in Python, and here I'm used for the example. So first of all, here I'm create for the adjacent list, and secondly, here I'm create for the adjacent matrix. Okay. So you can see here first create example for the adjacent list is node point to a list of the node it is a connected to. So you can see here I'm opening for in this the pie chart, this code editor, and here in this include and create example for adjacency list representation of a graph. Okay. So you can see first of all here and type for this the graph. Okay. So graph and then is equal to use this curly brackets. So this inside first of all I'm create the alphabet character of A and then clone just use for this parenthesis inside include for the character of B and again include for in this inside of C. Okay. And then going the next line of code and first of all here I'm type for the character of B and A. Use this again this square bracket. So in this inside I include for A and then include for here the D and again include for the character of E. Okay. So you can see here is second order and next time create for again uses for the matrix. So is a C. So now system type is perfectly and then use square brackets inside of include for here perfectly the character letter of A and in the character letter of A. Okay? And also created for you can see here and use for the D and D is print for only the character of B. Okay. Next time create for here the variable of E and this the graph theory and just here include for the character of B and again include for here is the M. Okay. And lastly here again uses for the alphabet character of A and then use for here the character of C and again include for here the character of E. That's it's properly create in this graph, this matrix and this adjacent list, and now I'm print for properly in this graph. So you can see I'm used so perfectly this type of print function and this inside I'm include for in this simple graph. That means here I'm properly create here the adjacent list representation of a graph. So now just can save this code and properly print for in this output. So as you can see here, it is perfectly print for the adjacent list representation of graph result. Okay. So I hope you understand it. So next topic here I'm create for another example here and use for adjacency matrix. So in this adjacency matrix, the graph is represented as a two-dimensional matrix where each cell Rij represents the presence or weight of it is between the node for I and J. Okay. So now let's create. So you can see, first of all, I'm removing in this all code and here I'm just type for the input, use the library package of numpy else in okay. And now just create the adjacency matrix representation of a graph. So first time type for A, B, J, type adjacency and type for is a matrix. Okay. And is equal to type for np dot in this the array and inside of include this in include this include for include this the value So first of all here I'm type for is a 0 and 1, then again 1, then 0, 0 and 0. Okay. And next time print for here. So you can see I'm beginning with the square bracket. So first of all type the 1, 0, 0 and then type for again 1 and the 1 and also for the 0. And also print it here. So you can see here I'm used for again the square bracket. So this inside I include for 1 and use for in the 0 for 1. Okay. And also, so first of all here use for the 1 and then I'm used for again this square bracket. So this inside I'm include for, so first of all type for the 0 and the 1 and then type for here is a total of the 4 0. Okay, so you can also simply create in this a matrix. So now just going here in this line and just in print for in this the adjacent matrix. You can see use the print function. This inside I include for in this adjacent matrix. That should also properly create the adjacency matrix example. Okay, so now just I am perfectly saving this all code and just click on in this the run buttons and let's see the output. So you can see here I'm just going and see the result is perfectly print for its adjacency matrix. Okay, so that's it for the today's tutorial, and here I'm properly defined for the graph theory is a fundamental concept used in the various fields, and the Python makes it easy to implement and the visualize graphs using this the adjacency list and the matrix. Okay, so next tutorial I'm properly create the key algorithms for the DFS and the DFS. So now let's see the next example. So that's it now the students tutorial, and I hope you are enjoying in this tutorial. Okay, so now just thanks for watching and happy everyone, and welcome back to today's another tutorial topic. So today I'm explore for here is the two important graphs traversal algorithm like the breadth first search for the DFS and the depth first search for the DFS. These are fundamental technique for visiting node in a graph. So now let's see in this code and see for how this algorithm works in Python. Okay. So first of all, here I'm explaining for the breadth first search. So indeed, the breadth first search explore for all nodes at the present depth for the level before moving on to the nodes at the next depth level. And indeed, the DFS is often used in shortest path algorithm and can be easily implemented using a TQ. Okay, so now let's see how to do this in Python. So you can see first of all I'm in boot for in the TQ. So first I'll type for here the from and then type for is the collections and then import for here is a DQ. Okay, and next time use for the DFS algorithm, so just enter for the deep and then simply use for the DFS, and this inside I'm include for here is a graph, then use for in the start attribute. Okay, and next time just type for here it's a visited is equal to type for in this the set this function, and here type for it's a q is equal to declare here is a TQ, and this inside I include for in this the start method. Okay, and now I'm integrated the visited dot apply in the add method and include this is a start. Okay, that's a perfectly great, and now here I'm used for in the while statement and define for in the queue. Okay, first of all I'm type for here is a properly in this the node is equal to declare this q dot use for here is a pop left. Okay, and use for the properly the spring function first of all include the node and also include for the endpoint and then quotations. Okay, and next time here I'm explore is a neighbor, so just have to have the for loop and then create for is a neighbors. So is perfectly typed in the graph and include for this node. Okay, And now I'm here used for the if statement, and then typer is a neighbors is not in the visited this graph. And just going the next line of code, and here I'm type for is a q dot apply for in the append this function include for in this the neighbor. Okay, and again created in this the visited dot apply in this the add method, and again include for in the neighbors. So that's what is perfectly great, and now I am here is properly defined. So you can see just to properly define the graph is the adjacent list. Okay, so you can say first of all I am type for into the graph is equal to create this curly bracket. So first of all I'm type for 1 is clone, and then the element is 2 and 3, and next time use for the here is 2 and include for the element 4 and 5, and also here I'm use for the 3 and then include for only the 6. And next include for the 4 it's include for the empty square brackets, then 5 is include for again the empty square brackets, then apply for 6 is use for again the empty square brackets. Okay, is a perfectly great now. And just I'm going this next line of code, and here I'm properly use the print function. So it's perfect, and this inside I will include for the output message. The first time create the program for DFS is a traversal starting. Okay, so starting from the node is a 1. Okay, and traversal. So you can your untab is perfectly is a done. And then here I'm just use for in this the DFS function include for the graph. So sorry, is properly defined as a graph. Okay, and again here I'm just declare the graph, and the node is a 1. That means here I'm properly implement for here is a DFS using a queue, and in this the graph is represented as an adjacency list for starting from the node is 1, and explore for all is a neighbors for the before moving to the next level, and as each node is the visited and printed the order of the traversal. Okay, so you can understand in this example, and now just saving this code and just click on in this the run button. Okay, so as you can see here in this the DFS start at the node for 1 and visited node for 2 and 3, and the continue to node for here is a 4, 5 and 6. Okay, so I hope your understanding is a DFS. And next example here I'm click for the depth first search for the DFS algorithm. So in the depth first search for the DFS Explorer has sorted down all branches of the graph as a possible. Can is a before backtracking, it can be implemented using a stack or the recursion. So now let's see how the DFS work in the Python. Okay, so just going for with the next line in this code, and first of all here I'm create for the another function. Okay, so you can see here I'm type for the div, and here I use for the DFS, and this inside I'm include for is a properly the graph, and then declare it's a node, and also declare here it's a visited is equal to therefore is properly in this the node. Okay, next time here use for the if statement, and then type for the visited is the node. Okay, and then going for and again uses for the visited is equal to apply for if state functions. Okay, and now here I'm use for in this the visited dot apply in this the add method. So here I'm include for this node, and then use the string function, then again declare the node and use for the end point is the empty disk square in this parenthesis. Okay, and Next step here, I am explore the neighbors. So just I'm going for, and you can see here I'm used for in the for loop. And first time before using the while loop, and now I'm just using the for loop and declare is a neighbor in the graph, and include for here is a properly in this the node. Okay, and the same used for if a statement and declare the neighbor is not in the visited graph. Okay, and also uses for the DFS. This instead of properly include the graph and also included is a neighbor and also included here is a visited graph. Okay, so you can understand it perfectly and just going in the next line of code. And first of all, I am copy for in this code now. Okay, and just paste for the next line, and you can see here I'm change for it's a DFS, and first I'm create the new line, then create the DFS traversal starting from node is 1, and just remove this DFS, and here I'm include for is a DFS. That's just perfectly done, and here is a this is the DFS implementation, and here I'm used for the recursion to explore each branch as deeply as possible before moving to the next. Okay, so in this function part, the DFS is recursively visit node and print them in the order of the traversal. Okay, so you can understand in this code. And now just I am properly saving this output and just click on in this the run buttons. Okay, so as you can see here is a properly print for in the DFS start at node for 1 and explore as the deepest possible into node for 2, 4, and 5, and before the backtracking, the node is a 3 and then continue to node for 6. Okay, so that's it for the today's tutorial. Here I'm properly explore for the two essential graph traversal algorithm like the DFS and the DFS. Okay, so you can see here in this the BFS is explored nodes level by level and why the DFS deep into its branch before backtracking. Okay. So now just thanks for watching the tutorial. Okay, and happy coding. Hello everyone and welcome back to today's another tutorial topic. So today I'm explaining for the world of hash functions and hash table. So these are critical data structure used for efficient data lookup. So it's well to break it down and look at here the two examples to understand for how they work in Python. So now let's get started. Okay. So you can see first of all I'm explaining for what is a hash table. Okay. So in this, the hash table or the hash map is store data in a key value pairs. And the key is a hash to determine where the value should be stored, making lookup very efficient. So here I'm implementing a simple hash table, and in this the Python use dictionary are an excellent element of hash table and in this action. So you can see, so before I'm just after creating the hash table, so first I'm create the hash functions, and just starting this program is starting for the hash function. Okay, so you can see here I'm explaining for the hash function. So in hash function take an input and the product a fixed size outside for in the output. Usually a number in this Python built-in hash function is used to generate the hash value for object, and this value uses store data in way that allow for a first access. Okay, so you can see first of all here I'm using for the Python's built-in the hash function. Okay, so now let's see the example, and here I'm creating the hashing different object using the hash function. So first of all here I'm type for, you can see this is a string. Okay, and then underscore include for in this the hash is equal to apply for in this hash function. This inside I will include for the message for hello. Okay, and just to create for another the variable is the number is a hash is equal to use for the hash function include for the number is the 42. Next time create for here is a tuple underscore in this hash is equal to properly apply in this hash function inside include the tuple of number is 1, 2 and the 3. Okay. And now just on display for the hash value. So you can see first of all here and use this print function and this inside and included for here is a suppose type for here. So this is a hash of, okay, so hash of and create this clone and then and use for the square bracket this inside I include for the string hash, okay. And just I am copy for in this code now and just I am paste for in this the next two line, okay. So you can see here I am use for the hash number, so just remove this string and here I am include for this is the number hash. And next time include for here is the tuple this hash. That means here I'm properly using for in the hash function on a string a number and a tuple. And the output is a hash value of its object which is an integer. Okay. So you can understand and now just properly save this code and just click on in the run button. So here in the tuple hash, okay, so now just perfectly clear you can see here I've created the double quotations, okay. So this one is a perfectly create, okay, and now just I am again save this code and just click on in this the run button. So now it's perfectly working. So you can see here first is print the hash, the string, then number and the tuple. That means in the hash value are unique integer generated based on the input data. The string use this hash value to store and the rate type data in hash table at the same. Okay. So I hope you understand me. Okay. So next topic here I'm creating for the hash table. So already here I'm explaining for the hash table and I'll just direct creating and implementing a simple hash table. Okay. So here I'm using for the Python dictionary are the excellent example of the hash table in action. Okay. So you can see here I'm just remove for properly this the all code. Okay, so first time type for you can see here is a hash underscore. This is the table is used for empty curly brackets. Okay, and now here I'm inserting the key value here. So first time type for is a hash table, and in this inside I'm include for the column is a name, and just inserted for here the name is in Alice. Okay, and a system here I'm again defined for the hash table. And this inside I am just include for the variable just name for is a age, okay, and is equal to use for the 30. Then I am apply for again use in the hash table and there is square bracket inside of include the properly in the city name, okay, and must be is always uses for in this the city name it's a new year because it's a easy, okay. Is done. And now the accessing for the values using for the key, just type for is the print function and this inside and type for first just type this easy name column. And here I'm define the hash table. Then square brackets inside and include for here is the name this variable. Okay, so you can understand. And now just copy for in this code and paste for here the next two line. Okay, and since this one supposed to include the name and now I'm defined for here the age and also here I'm declared the output for this is a city, okay, and the hash table. So here I'm making remove, so include for the variable of age and here I'm include for is a city. That means is perfectly here and use a Python dictionary to represent a hash table and store here the three key value here and the person name is in the city. And when just access in this the value in the key And Python is perform hashing behind the scene to quickly retrieve the data. Okay, so you can understand. And now just I'm properly saving this all code and just I'm click on in this the run buttons. Okay, so as you can see here, you can perfectly see the result and can properly access the value for is a instantly using the key. So you can see the name Alice is 30 and the state for the neighbor. And this is the power of hash table allowing for the quick lookup time. Okay. So now that's it for the today's tutorial. Today properly explore for the hash function and the hash table in Python. Okay. So now just thanks for watching and happy coding. Okay. Hello everyone and welcome back to today's another tutorial topic. So today we explore for the real world application of hash table in Python, including for here is the caching and the indexing. So these are the some of the most common use of hash table, making our program faster and the more efficient. Okay, so now let's see in this example. So first of all, here I'm explain for what is a hash table. So it is a data structure that stores the data in key value pairs for fast access, and the hash table allow the constant time lookup, making them perfect more use case like caching and the indexing. Okay, so here I'm using for the hash table for the caching. So one of the most common use of the hash table in the caching store provide previously computed results, so you can reuse them instead of the here is a create the recalculating. This can here significantly speed up the program, so let's implement a basic cache using a Python dictionary and with the function as a hash table. So here, first of all, I'm create a simple cache using a dictionary for the hash table. So you can see here, type for this is a cache is equal to use for this empty display brackets. So first of all, here I'm define the function is a expensive computation. So expense the expensive underscore this is a computation and this inside of include for the x. Okay. And next step here I'm used for the if statement for x in a this cache. And here I'm used for into the simple this print function. And here I'm type for is the fetching result for so fetching in this the result for this double quotes curly brackets inside will include for the x. Then also here I'm highlight from is a cache. Okay, you can understand. And now it use for here the return statement and define this cache and the square bracket inside include for into the x variable. And now I'm properly use for the else statement and create this another print function. So you can see here I'm type for is the computing result for x. Okay, so computing result for this the x. Okay, so you can properly understand it. Okay, so now the type for in this the result is variable used for the x and multiplication for x. That means here it is simulating an expensive computation. And then I'm defined for here. So here I'm mistakenly defining the dot is not now. So just as that for is a cache is include the x and is equal to declare the variable of result. Now I'm used for the properly in this the return statement and also declare in this result. Okay. And now just use in the print function and print for in this example. So first of all, here I'm type for is a expensive computation for the value is a 5. And secondly, create the another print function and then type for the expensive computation for again the 5. And again use this print function and also here include for this is the expensive computation for the 10. Okay, let's make this properly create in this example. here and create a simple cache using a dictionary. If a value has already been computed, it's a fetching from the cache. This is much faster than recomputing as this value isn't cache and compute it and store it for the future use. Okay? So you can proper understanding in this example. And now just I am perfectly saving this all code and here I'll just properly click this run button. So now as you can see here is a perfectly printed. First is the computing result for 5 for 25. Again 5 for 25 and 10 for is a 100. Okay. So the fetching result for 5 from the cache is 25 and computing result for 100. That is perfectly done. And next topic here I'm also using for the another example for the hash table for indexing. So another common applications of hash table is indexing where are quickly mapped to their respective data. Let's say build a simple example where use a hash table to index students' names and the retrieve their score. So you can see first of all I am remove for in this all code and next time create another new program. So here I'm using example for indexing with a dictionary like a hash table. The first time type for the variable name is a student underscore and the score and is equal to, so here I'm used for is properly this parenthesis and in this inside I'm include, so first I'm used for the student name informations and also the student's score. So first of all type the first student name is a Alice and the Alice score is a 90. Then I apply for the another student name like a Zohan and then Zohan exam score for 85 and again created for the another student. So you can see another student name is a Smith and the Smith score is a 95 and again created for the another student name like a Bob and the Bob score is a only for 88. Okay, so you can here is completely creating with the dictionary for the hash table and here I'm accessing the student score using the index for the hash table lookup. So use this print function and first of all here I'm type for the if and the double quotations then type for, you can see here I'm type the Alice. Okay, so Alice score. Here's the clone and then curly bracket inside include for the student score and declare the student name like a Alice. Okay, and then going the next line of code and use for the again the print function and here I'm included for its a here I'm used for the Zohan, so you can see type for the Zohan score. So I'm type the Zohan score is used this again calling this student score and include for the student name like the Zohan. Okay, that means is perfectly done this example and here I properly use a dictionary to index students names and their respective score and the dictionary act as a hash table allowing for the fast lookups by name. Okay, so you can understanding in this example and now just I'm saving this whole code and just I'm click on in this the run buttons. Okay, so as you can see here you properly see the result for Alice score is 90 and the Zohan score is a 95. Okay, so that's it for the today's tutorial. Here I'm properly create and see for the best practical applications of hash table like caching and indexing. So caching is help store the previously computed result, speeding up program performance, while indexing allow us to map key to data efficiently. Okay. So I hope you proper understanding in the student's tutorial. So now just thanks for watching and happy coding. Okay. Hello everyone and welcome back to today's another tutorial topic. So today I'm going to explore for the three key arithmetic technique like divide and the conquer, Brady algorithms and the dynamic programming. These are essential for solving complex problems efficiently, and here I'm properly covered the Python programming example. So now let's get started. So first of all, here I'm used for divide and conquer used for the merge sort algorithms. Okay. So you can see the divide and conquer is a strategy where a problem is broken down into smaller subproblems solved for individually and combined to get the final result. Okay. And a classic example is a merge sort just algorithm. See here. So you can see first of all I am create using the merge sort create the divide and the conquer. So you can see first time type for the function, and the function I create here is properly this is a merge sort. Okay, and then create this parenthesis inside I'm properly include for in this array. Okay, and now here I'm use for if then define the length. Okay, so it's create the length inside again created for this array, and here I'm defined for you can see. So first of all, okay, so now just it's properly not correct, so just remove and define for again and then type for in this length and also include for this simple of array and is greater than for 1. Okay, and now just go in the next line of code, and here I'm type for the medium is equal to define the length for array and then double forward is it 2. Okay, and next step here I'm type for is a left underscore this is a half is equal to properly defined array and this insert and include for increase the medium value. And just again create it now, so you can see just I am okay. So first time typer is a right underscore in this the half is equal to and here I'm typer in this array and then include for here is a me then clone. Okay, and next time use for here is a properly you can send define for the merge sort this include for the left half and again declare in this the merge sort and just include for here is the right half. Okay, that's which is perfectly correct now, and now I'm used for the I and the j variable I j k. So I is equal to j and is equal to k is equal to means 0. Okay, and now properly use for the while loop just create the I is less than define the length. Okay, so this inside first time declare here is the left half and create the algorithm for j and is less than define for the length and this inside and include for here is the right half. Okay, so you can understand, and then going the next line of code and here I'm use for the if statement and properly here I'm declare is a left half include the I variable and is less than and just some type for you can see the right half and include the j variable. Okay, and first of all I'm again declare the array and just include for the k and is equal to type for the left half. Okay, and also include again the I variable, and next time create for the I variable is incremented by 1. Okay, and next time use for indeed the while is it used for the else statement and then going also the next line of code. So you can see now just in use for properly defined you can so now just I am copy for in this line of code. Okay, and paste for in this the next line. Okay, So now we define for the array for t is equal to length half. Or here I'm just creating out length half, and here I'm include for this is a right half. And just include for here the j variable, and also here I'm type for j is incremented by 1, and then again define for here is a then plus equal to 1. Okay, so you can understand this properly, is perfectly almost done. Okay, and now I'm just here so go in this next slide. And first of all here I'm again use for in this the while loop, and create for I is less than for here is a length, and include for here is a left half. And just go in the next line of code, and first of all type for into the array, and then include for the k is equal to declare for here is a left half, and also include for the I variable. So first of all here I'm type for I is plus equal to 1, and then again create for the k is first of the plus equal to 1. Okay, is a perfectly great, and now just I am copy for in this code and paste for this the next line, and just change here. So first of all here and create the I variable, and now define for the j variable. Okay, and also just in here it will remove for the left half, and here include the right half. So again just declare remove for this is a right half, and just change the I variable include the j variable. Okay, so my code is almost done, and just here I remove for the I, and here I include for the j. Okay, so it's perfectly generated for the merge search algorithm, and now here I will create the example. Okay, so you can see just I'm going this next line of code, and first of all here I'm type for array, and is equal to include for the number of elements. So first of all here I'm type for the 38, then apply for here is a 27, then 43, then 3, 9, and randomly use for 82 and the 10. Okay, and now I'm properly declare is a merge sort, and this inside I'm include for in this array, and here I'm only print for, so you can see just I'm type for the print function and include for in this array. Okay, that means is properly created in this example, and here just break the array into the smaller sub array, is recursively sort each and then merge them the back for, and this how is divide and the compute works. Okay, so you can understanding in this example, and now just I am properly saving this all code, and just click on in this the run buttons. Okay, so as you can see here is a perfectly see the result for 3, 9, 10, 30, 27, 38, 43, and lastly 82, because the unsorted array is divided into halves until a word is sorted, and finally they are merged into a single sorted array. Okay, so I hope you understand it in this example. The next topic here I'm creating the greedy algorithms use the coin change problem. The greedy algorithms make a series of choices that seem best at the moment. So let's look at the coin chain problem, where I try to minimize the number of coins needed to make certain amount. Okay, so now let's try. So first of all I am remove for in these the all code. Okay, so now properly just select all and remove. And you can see here, first of all, I define for the function, and the function name like a coin underscore this is a game. Okay. And then in this include, first of all, I'm type for the coins, and second I'm define for its a amount. Okay. And next step, first of all, I'm declare the coins dot apply in this the sort method, and here I'm properly defined is a reverse. Okay, so not is reverse, only the reverse is equal to, that's a true. Okay, and now I'll just type for the variable is count is equal to 0, and now I'll properly apply in this the for loop. Okay, the first time type the point in the points. Okay, and use for the if statement, the first of all declare the amount, is greater than equal to its point. Okay. Next time we use for here is a count, then plus equal to declare for in this amount is double forward slash and declare in this point. Next time again create for amount is equal to type this amount and the modular just is type the point. Okay. And now I'm use for here the return statement and include for in this account this variable that was properly create in this the coin chain problem here in this example, and now just uses the example. So first of all declare the class is A. So you can see just type for is the coins is equal to, so here I'm include for the number of elements, so 1 5, then 10, and also for here is a 25, sorry, is a 25. Next time declare here is a amount. Okay, so amount is equal to just like a 68. And now I'm use the properly in the string function. So first of all declare the coin chain and also included here the properly coins, and you can see this amount. Okay, so that's it. Here properly use the sort the coins in descending order and keep choosing the largest domination that fits the remaining amount. Okay, so you can understand it. And now just I'm saving this all code and just I'm click on in this the run button. So as you can see here, they perfectly see the result is true. That means in the code sort the coin descending order, and here the number of coin by always choosing the here the variable coin, and here the make the 6 turns to the 68. Okay, is done. And next topic here I'm also creating this is a now creating for the dynamic programming like uses the Fibonacci sequence. So dynamic programming is a technique where you solve the problem by breaking them into smaller sub-problems and sorting the result to avoid the redundant calculation. So now let's see this example. Okay, so you can see I'm just remove for again in this the all code. Okay, so just is remove. And first of all, here I'm create another function name is a Fibonacci. Sorry, I'm just not used. So this one is a perfect. And this inside I'm include first is in. And also here I'm type for Nemo. Then is equal to use this curly brackets. Okay. And now I'm just use for the if statement if in the Nemo. Next I'm use for here the proper integer written statement and then type for Nemo and the square bracket inside include the in. And now I'm again use for in this the if statement, then type for declare the equations for n is less than equal to 1. And then I'm again apply integer return for n. Okay. And now I'm finish for here is a Nemo then n and is equal to declare here the properly the Fibonacci. This inside and create for n minus 1 and also create in this memo. And use the additional operator and include it for Fibonacci and just again create it for the series for n minus 2 and also define this name. Okay. And now let's properly use the return statement and include for the memo and include for in this the end. That's it's perfectly almost done. And now I'm use example and just use the print function and just include for the Fibonacci and the element of 10. Okay. So that's just a simple program here and use the dictionary to store the result of the previously computed Fibonacci values, avoiding the repetitive calculations. Okay. So you get understanding in this example and now just save and perfectly see the result. Okay. So you can see here the properly print for the output is a 55. That means the dynamic programming speed up the completion by ensuring that its reference number is calculated only all the storage for the future reference. Okay. So that's it for the today's tutorial, and here I'm properly creating the concu and here I'm defined for the is essential algorithmic technique for divide and conquer, greedy algorithms, and the dynamic programming. Okay. So now just thanks for watching and happy coding. Everyone, and welcome back to today's another tutorial topic. So today I'm covered for the three basic sorting algorithms like bubble sort, selection sort, and the insertion sort. So these sorting techniques are great for understanding for how data can be arranged in an efficient manner. So first of all, here I'm creating the bubble sort. Okay. So this algorithm repeatedly steps through the list, compare adjacent element and swap them if they are in the wrong order. So it's a simple but not the most efficient for the large data set. Okay, so you can see I'm just starting and create the bubble sort in the Python. So first of type the function is div and the function name like say bubble underscore this is a sort. And here I'm include for English the symbol of array. Now yes one here is a length and this inside I'm include for this array. Okay. And now we apply for into the for loop for I in the range and then include the number of n. And here I'm use the for loop. So for for j in the range, and then here I'm first to include the 0 and second we include for n minus I and then minus 1. Okay. And next I'm use for again the if statement and declare for index the array of index j. Just in this inside I'm create the j and is greater than again type for array and the index for j and plus operator for 1. Okay. And now just type for index the array and just include for the j variable and also create for index the array and include for the j and the plus operator for 1. Okay. And just again created for index array for the j include for the j and the plus operator on and also created this array index of j. Okay, so you can see here the completely create this example. Okay, so now I'm create for the example for index the bubble sort. So just going for here. And first of all, here I'm type for index the symbol of array is equal to. So here I'm include for the number of elements. So first of all, that is 64, then 34, and then 25. I'm randomly type is 12, then 22, and here is the 11, and also for the 90. Okay. And now properly define the bubble sort, include for index the array, and just use the print function. And first of all, here I'm type for this is a sorted array is and then declare simply for in this array of elements. Okay. So you can see here is a perfectly create in this the outer loop runs through the integer array and the inner loop swap adjacent element and if they are out of the order. Okay. So you can understand perfectly and now just I'm saving this old code and just click on in this the run buttons. Okay. So as you can see here is a perfectly print for the sorted array is the result. Okay. So that means for in this the result for after running the bubble sort, they are in now sorted in ascending order. This algorithm is straightforward but not efficient for large array as it stands the complexity for 0 and O and N for a square. Okay. So I hope your understanding is a bubble sort. And next I'm creating here is a selection sort. Okay. So this algorithm select the smallest element from an unsorted list and swap it with the first element and then move on the next position. Okay. So you can see just I'm going for in this code inside and remove for it's a create now bubble sort. Here I'm type for is a selection. So selection sort include the array and use for. So perfectly here I'm apply is a for loop. Okay, so just remove this one. First is use the for I and the range and this inside and include for. So you can see I'm just type for is a length. Okay, and then include for this inside in this array. And next step here I'm just type for is a minimum underscore is id x is equal to for I. Okay. And then apply for here is a for loop or for in. So just remove in this example just code, and here I am properly include for I and plus operator 1. Declare for in this the length and this inside and properly include for this array. And use for the if statement for j is, then I'm change for in this sign and array, and just I'm remove this, and here I'm include for is a minimum for in this index. Okay, and just create for, so now just go in the next line of code. And first of all here I'm type for minimum index is equal to j. Okay, so is the next line, and then I'm apply for the array of I, so is remove for j and include the I, and also change for j and 1, and here I'm include for the minimum index, and also change include for again the minimum index for I, array of I. Okay, so you can see here is a perfectly done, and now just I am remove for in this code, and here I'm apply for is another element for 29, then apply 10 for 14 and 37, and also for the 40. Okay, so again uses for this double uses, and just I'm change for in this bubble sort, and here I'm include for this is a selection sort and include for in this array. So now just creating for the sorted array is this array. You can see in this the selection sort find the smallest element in the is pass in the move to the beginning of the array. So you can understanding the selection sort, and now just I am saving this all code and just click on in this the run buttons. Okay. So as you can see here, the perfectly see the sorted is 14, 14, 10, 20, and 37. That means indeed the selection sort give us a sorted array by repeatedly selecting the smallest, and you can see indeed the element. Okay. And so it's easy to understand, like the bubble sort is also has the time complexity for output and style. Okay. So I hope you're understanding. Okay. So next topic here I'm creating for the insertion sort. So finally, the insertion sort, this algorithm builds the sorted array on element at a time by comparing the current element with already sorted part of the array and placing it in the correct position. Okay. So now let's create this example. So you can see, first of all, I'm change this one, and here I'm create the proper insertion sort. Okay. So insertion sort include the array and use for the range 1. Okay, so first of all I'm type for the 1 and then the length for array. Just change this, and here I'm include for this is a key is equal to type for array index of I. Okay, and next I'm use for here, you can see just type for the j is equal to include for I is decrement for 1. Okay, so now I'm just remove for Indian the all of code. And first of all, here I'm applying is a while loop, and just create j is greater than equal to 0. And apply for here is the key is less than, declare properly this array include for index of j. Okay. And then type for in this array, then include for the index j and the plus operator for 1. And is equal to again this array just include for the j. Okay, and now grade for the j is decrement equal to 1, and again define for the symbol of array index j and plus operator for 1, and declare is proper into the key value. Okay, and also here I'm just create for in this array, change this for numbers. So here I'm use for the 12, 11, then 13, 5, and 6. And now just print for here is insertion sort. So you can see, just type for the insertion sort include for the symbol of array. So you can see here is a completed create this insertion algorithm. Just assume the first element is already sorted, and then insert each subsequent element into its the correct position in sorted part of the array. Okay. So you can understanding in this example and now just see the result. Okay. So just click on in this. So just fetch for the simpler problem. So you can see the key in this array is not defined here. So just again check this code and now let's run this. So now just I am properly again. Okay. So just perfectly save and just also click on the run button. So now it's perfectly print the output. So here is greeted the sorted is 5, 6, 11, 12 and 13. That means here the insertion example for is give a sorted array repeatedly moving each element is to correct position. Okay. So here that's it for the today's tutorial and here I'm properly create the 3 fundamental sorting algorithms like the bubble sort, selection sort and insertion sort. Okay. So I hope you proper understanding this tutorial topic. So now just thanks for watching and happy coding. Okay. Everyone and welcome back to today's another tutorial topic. So today I'm creating and cover the 3 essential sorting algorithms used for efficient sorting of large data set like merge sort, quick sort and the heap sort. Okay. So and walk through each of these algorithm with Python code and example. So now let's get started. So first of all, here I'm explaining for even merge sort. Okay. So merge sort is divide and conquer algorithm that divide the array into halves, sort them recursively, and the merge sort them back together. So merge sort has a time complexity of 0 and log n and making it efficient for a large data set. Okay. So now let's create this example. So you can see first of all here I'm typed the diff function and the name is a merge sort. Okay. And this insert and properly include in this the array. So now just type for if and then type for is the length is object and this insert I'm include for in this array. And then type for is the greater than like 1. Okay, and now the same type for mid is equal to again define for this length included for in this array in double forward slash then 2. Okay, and here type for is the left and in this the half this node and is equal to type for this array and then use for here is a minimum value. And next time here I'm again type this is a right underscore is a half and is equal to type for in this array and then include for in this mid then floor. Okay, is it perfect? And first of all here I'm defined for the merge sort then include here is a left half and again this type for you can see the merge sort and include for here is a right half. Okay, is it perfect? And then type for I is equal to j and j is equal to k is equal to 0. Okay, is it perfectly create done? And now just apply here is a while loop. Okay, so you can understand here I'm type for in this the while and then include for I is less than for this length. Okay, sorry, it's not now. So only custom type for in this the length and this include here is the left half. And now in create for here is j is less than declare for in this the length of object and include here is the right half. Okay, so you can perfectly understand. So now I'm used for again the if statement and define for the left half index for I and is less than just type for the right half and index of j. Okay, and now I'll create for the array of index k is equal to type for here is a length half and include for the I variable. And next time create for the I variable increment by 1. Okay, and now we'll use for in this else statement and then type for array of index k is equal to just type for the right half and index for j. So just the same process for the j is plus equal increment for 1 and then it's create now. So k is plus is equal to 1. Okay, so you can see here is already created my code and apply for here is a perfectly. So now just I'm going for the next line of code and here properly I'm defined. So Just going the next line of code, and here I'm used for again the while and create for j, sorry, is I variable is less than, here is the length, and this enter I'm include for the left half. Okay. And now I'm just copy for in this code. Okay, so just copy and then paste for here the next line. Sorry, is it? Okay, so this code is perfect. And okay, so now let's say perfect now. Okay, so you can see here I'm used for the J is left half and array K, then it clear here is a perfectly it's a left half and include for here the index of I variable. And you can see change for the J include the I and also for K is 1. Okay. So you can understanding in this example, and now just I am again copy for this code and paste for here the next line and just change. So you can see here I'm include for this is the right half and just change and include perfectly it's the right half and change the variable value is a variable for the j is increment one and the j. Okay, so you can see here the completely correct for the merge sort algorithm. And now I'm used for here the next line of example. So you can see just in type for array. Okay, is equal to, so here I'm used for the randomly the number is 45, then 56, and 22, then 33, then 78 and 90. Okay, and now I'm properly defined for the merge sort and include for in this array. So now I'm used for the print function and printing for the sorted array. So sorted in this array, and now I'm properly call this array. Okay. That means in this the example for the merge sort is work by dividing the array. Recursively sorting is half and then merging them back or together in sorted order. Okay, so you can understanding is perfectly correct this example. And now just I'm properly saving this all code and just click on in this the run button. So you can see here I'm pitched for the simple arrow. So 32 lines, 7 and 27. Okay, so now just I'm properly create. So you can see the 7 line. Okay, so now just check this is was strictly defined for the left half and the right half. Okay, so this one is a perfect, and then again going and then 32 line. So is a merge sort include for this proper in this array. Okay. Okay, so this code is perfectly done. And now just I'm again try. So just I'm select all again and just click on in this the run buttons. Okay. So now it's perfectly working, and in this sorted array for the 3, 22, 25, 7, 38, 82 and the 90. That's mean here is the merge sort the array efficiently used in the recursion and the merging. Okay. So you can see here is done for the properly in the merge sort algorithms. And next I'm creating here the quick sort. So quicksort is another divide and conquer algorithm. So quicksort pick a pivot element, partition, and the array around the pivot and the sort the partition. Quicksort has an average time complexity of 0 log n log, but can degrade to 0 the n square in the worst case. Okay. So now let's create this example. So you can see first of all here, I am just going this one and type for the function name is a. You can see just type for is a quick sort. Quick is a quick sort and use for the if the length for array and just change this sign. And here I'm used for is a less than equal to 1. And here I'm used for in this the, so now just I'm remove for in this the all of code. Okay, and then just, so you can see first of all here I'm type for is simply define the return statement. So just I'm type for, you can see the return statement for in this simple of n. Okay. And now I'm declare here is a pivot table and is equal to declare this array and use for here the length and include properly this array. Okay. And then forward slash word for is 2. And now first of all here I'm type for is a left node. So left is equal to use the square bracket inside and include for x in the array and use for the if x variable and also this less than is a pivot. Okay. So you can see here is a completely create perfectly and now just I'm copy for in this line of code and paste for is the next two line. Okay. So you can understanding and perfectly understand change for the left and here I'm include is the middle point and here is a right point. So just in type for is a right. And since we understand, so here use the x for x in array if is equal to this pivot and then the right is that x for x in array is a greater than for this pivot. Okay. That is almost perfectly done and now use for here is a return statement and then declare is a quick sort and this inside I mean for here is a left and also they create the middle and the concatenation and again declare the quick sort and this inside I include for here is a right node. Okay, so you can see here is already created in this code now and perfectly just going for into the array inside. Okay, so just remove for in this number of elements. So first time type is 10. Then apply for here is a 7, 8, 9 and 1. Then 5. Okay. And now change for in this the merge sort and here we include the quick sort and we include for this array. Okay. So that is completely done in this example topic. And here I'm create the quick sort select a pivot partition the array for into the still elements less than and the greater than the pivot and recursively sort them. Okay. So you can understanding in this example and now just I'm perfectly saving this all code and just I'm click on in this the run buttons. Okay. So as you can see here is a perfectly see the sorted array for 10, 7, 8, 9, 1 and the 5. Okay. That's why you see the quick sort has efficiently sorted the array. So quick sort is often faster in the practice, so it can be degraded performance in the sum case. Okay. This is a sum case. So now just complete done the quick sort. And next topic here I'm also created here is the heap sort. So heap sort is based on the binary heaps data structure, first building a max heap and then the sorting the array by removing the root node one by one. And heap sort is always run for the zero log and time. Okay. So now let's create this proper example. Okay. So you can see first of all I'm remove for in this code. Okay. So you can see just I'm type for the function name is a heapify. So HEAP then is a heapify and now I'm include the first one for the array, second in and also for the I. Okay. And now just remove for in this code and first of all here I'm type for is a largest element for I. And then type for is a properly left is equal to 2 and the multiplication sign for I and the additional operator for 1. And then just I am. Okay, so is the next line right now. So now I'm just copy for in this code. Okay. And paste for the next line and change is a left node, it's a right node. Okay. So is a right and then change for the 2 multiplication and the number of 2. Okay. So you can understanding and then going the next line of code and first of all here I'm type for the key and define for is a left is less than in and also type for the array of index declare the left. Okay. And then here I'm use for the greater than and type for the array and then include for here this is the largest. Okay, so now just I'm again type for the largest is equal to define for is the left. So this one is a perfectly this left. Okay. So you can understanding in this code and now just I'm perfectly save in this all code. Okay. Sorry, is copy this all code and paste for just okay. So you can see here I'm paste now and again then paste this code. Okay. So now just I'm changing first to create the left node and just create the right node. So R is the right and in and the here and include for is properly this right and the largest, and again change, so include here the right. And next I'm use for again the if statement. So first of all here I am remove for in this all code. Okay. So first of all remove the if statement and declare the largest value. And is the not is equal to for I. Okay. And also in the next line of code, and first of all here I remove this, and you can see here I'm create. So first of all define for the array index of I. Okay. And also here I'm create for the array index of the largest. Then is equal to type for the array of index like largest, and created for this array of index is a I. Okay. And now I'll just declare for the copy 5. This include for the array, then in number, and also create for the largest value. Okay. So you can hear the perfect understanding, and now just in creating for here is a heap sort algorithm. So now I'm just here, and first of all define for the another function name is a heap underscore, this is a sort. And here I'm include for in this the symbol of array. Okay. And now first of all type for n is equal to type this is a length index for the array. And now I'm properly define the for loop for I in the range. And here I'm include for n is double forward slash is 2, decrement 1 and increment 1, and again for this one. Okay. And now I'm just calling for index copy this method and include for the array number of n and also create this I variable. Okay. So you can see here is a perfectly create, and now just I'm again create this for loop and I in the range and include it for here for in minus 1 and 0 and again for minus 1. Okay, so now just declare for in this array of index I and define for the array of index 0, and x is equal to type for array of index 0. Then also created for array of index for I. Okay, so you can see my code is already done, and here I'm declare for the copy and include for the array secondly I variable at the 0. Okay, so you can understanding perfectly. And now I'm used for the example. So first of all here I'm just use for the another value number of 11. So you can see first of all here I'm type for the 12, then 11, then 13 and 5, then 6, then 7. Okay. And now I'm properly declare here is a heap sort. So you can understanding the heap sort and include for this simple of array. Okay, so you can understanding here is a properly defined for indeed the algorithms for the creating a maximum heap and swapping the root with the last element and the repeating the process to sort the array. Okay, so now I'm just perfectly saving this all code and just click on indeed the run buttons. Okay, so as you can see here is a perfectly sorted array for 5, 6, 7, 11, 12 and the 13. Okay. So that's it for the today's tutorial. Today I'm properly covered for efficient sorting algorithm like the merge sort, quick sort and the heap sort. Okay. So now just thanks for watching and happy coding. Everyone and welcome back to today's another tutorial topic. So today I'm creating the compare the efficiency of two common sorting algorithm in Python like the bubble sort and the quick sort. So here I'm using the Python code to highlight their difference in performance, focusing on both the time complexity, okay, and the practical runtime. So first of all, here I'm create the bubble sort. Okay, the bubble sort is a simple weight efficient sorting algorithm is repeatedly step through the list, compare adjacent element and sort them if they are in the wrong order. And while easy to implement, the bubble sort has a time complexity of 0 and O and then N whole square, which make its efficiency for large data set. Okay. So now let's create. So first of all here and import for is a time. Okay. So I'll just type for import for this time. And now this starting for here is a bubble sort in algorithm. So type for is a function and is properly typed. You can see the bubble sort algorithm and include for simple of time. Okay, so now just when the next line of code and here I'm defined for in is equal to is a length and include for simple of array. And now we use for the for loop in for I and use for here the range and this inside I'm include for the in. So now I'm just again use the for loop for j in the range and include for the 0. Sorry, first of all this parenthesis and 0 and in minus 1. Sorry, I'm first just type for the minus I and always the minus 1. Okay, so perfectly define the two for loop and now I'm apply here is a if statement. So include for the array of index j and here I'm also created now. So you can see just and now I'm create for here is a greater than sign and just again created for array and index for j then plus operator for here the 1. Okay, and just doing the next line of code and here I'm type for array index of j variable and again created for the array index of so j and then plus operator for 1 and is equal to again created for the array index of j is j and then plus operator for 1 and next time created for the array index of j. That means here is a perfectly create almost in this code. Okay, so now just I'm going the next line of code and here I am create example use and the time comparison. You can see here I'm type for the array and is equal to use for the number of elements. So first of all type for the 64, then 34 and 25, then 12 and also for the 22, then 11 and lastly I'm apply here is the 19. So first of all here I'm type for is a start time. So start underscore is a time and is equal to declare the time dot use for here is a time functions. And now I'm calling for the bubble sort and include for the simple of array. Okay. And next time just type for here is the end underscore in this that time. And is equal to again use for the time dot apply in this the time method in this function. And now I'm used for here is a print function and this inside I'm included for the output message. So you can say just type for the socket array using the bubble sort. Okay, so bubble, so I'm just type for you can see the bubble sort and then include it for in this simple of array. Okay, so here is almost is completely done this my code and now just I'm again use for the another print function and then here I'm include for is the bubble sort time. Okay, and first of all I'm use as in time is decrement for here is a start time and then I'm used for again these double quotations and this inside I'm include for here is the seconds. Okay, that means here in this the Python for implementation of the bubble sort and the measure the time it take to sort a small array. Okay, so you can understanding in this example and now just I'm saving this all code and just click on in this the run buttons. Okay, so now just as you can see here the sorted array using the bubble sort this the time and you can see here the bubble sort time in this second. Okay, so now just here is used for the 00. So because I'm just again check this code and just again then run. So now just again save this code and here it's not previously expected output. So now just check again. So you can see here is the same for because it's used for the 0.0 second. Okay, so that's it for in this example for the bubble sort. And next topic here I'm creating the quick sort algorithm. So quick sort is more efficient algorithm. So quits are used to divide and conquer approach to partition in the list and the recursively sort, and it has an average time complexity. Okay. So now let's create this example. So first of all here, I'm just going here and just remove for indeed the bubble sort. Here I'm type for is a quick sort and define. So now you can see just I am remove for in this simple of both. Okay. So you can see first of all here I'm type for if and then type for the length and include for the array and use for the greater than equal to this is less than equal to 1. And now I'll perfectly use the return statement for in this simple of array. And now I'm apply for here it's a pivot. The pivot or pivot is the same and then use for the array and in this inside I'm include for the length this inside include the array and here is the right for is a 2. Okay. And now we use for here is a left node. So the left is equal to. So you can see first of all I'm type for x in the array and use for if the statement for x is less than this is the word. Okay. So you can understand and now just I am copy for in this code and paste for the next line and again just next. So you can and now I'm just change. So first of all I'm create for the left node. So now here I'm include for it's a middle node and change for any sign and here I'm use for this equal to and just now type for here is a right node is equal to for x for array and the change for in this sign so here I'm used for is a greater than. Okay, so that's almost is perfectly done and here I'm used for the return statement. So you can see here I'm type for the quick sort and first of all here I'm used for the left node and the plus operator and then type the middle and again this one and here I'm type for you can see the quick sort and include for here is a right node. So that's it, here is almost completely done in this code and here I'm uses the example for comparison the time complexity. So here use the same this array of elements. So starting time then sorted. So here I'm include for. So first of all here I'm create the start time and then here I'm first of all type is a sorted. So the sorted underscore this is a time. Okay, and is equal to so here I'm use for you can see the quick sort. Okay, so you can see here use a quick sort and include for use the simple of array. Okay, so now I'm use for in this the same of the code and just I'm change for here I'm just created the sorted array using for the quick sort. So remove this bubble sort and here I'm include for it's a quick sort and also change here. So just type for is perfectly you can see this is a quick sort the time endpoint and starting the second. Okay, that means here the Python implementation of the quick sort is notice how it's partition the list arrow is a pivot and the recursively sort is per. That measure the time and take the sort the same array as before. Okay, so you can understand it. And now just I'm saving this all for and just click on in this the run buttons. Okay. So as you can see here is a perfectly sorted using the sorted and here in this same of time. Okay. So now I'm just here import for is a bubble sort algorithm just press here. So here I'm just simply change for in this element. So just I'm type for the 60 then use for the 30 and then use for the 20. So now just again save this code and just click on this the run button. So as you can see here you perfectly see the quick sort is comparison for here at the same time is different the time complexity. Okay, so you can see here is done the two tutorial. So here I perfectly compared the two sorting algorithm. First I'm create the bubble sort and secondly I'm creating the quick sort. And while the bubble sort is simple, it the zero and the n square complexity make it insufficient for large data set, and the quick sort with a zero and log and log complexity is much faster and the scale better for the larger input. Okay. So I hope you are understanding this tutor. So now just thanks for watching and happy coding. Okay. Hi everyone and welcome back to today's another tutorial topic. So today I'm exploring for the two fundamental search algorithm in Python like the linear search and the binary search. Okay. So now just this code implementation and compare their efficiency through the real world example. So first of all, here I'm creating the linear search. So this algorithm is straightforward. It goes through its element in a list one by one until it finds the target value. This makes it simple but insufficient for the large data set with a time complexity of 0n. So now let's see it work in Python. So you can see first of all here I'm defined for the function state and then type for this is a linear search algorithm, and here I'm include for perfectly the array, and second here I include for the target value. Okay, so next step here I'm use for the for loop for for I in the range, and here include for here is a this parenthesis include the length, so le, and the length include for in the simple of array. Okay, and now we use for the if statement defined for this array index for I and is equal to define this as a target value. So now we use for here is a return statement for I. Okay, and next time again uses for in this the return then decrement for 1. Okay, so you can see here is a create for this linear search algorithm in Python. And now just use for the example, so you can see I'm type for the array and then insert for the elements. So first I'm type for the number of element 10, 23, then 45, and also here it is 17, then 11, and last time create the 15. So now just define for here is say target value is a 70. Okay, and now just to create for is a simple index is equal to declare the linear search and this insert and include properly array and then target. Okay, so you can understand. And now just do the string function. So here I'm include for this is in linear search and algorithm says ERCH. Okay, is that perfect? And then type for this is you can see the element so is a found at index. Okay, and then define this properly in this the index. Okay, so you can understand it in this a linear search. And in this example here, I'm defining a simple implementation of linear search. And just throw, iterate the array to find the largest value of 70. The functions return the index of the target if found, otherwise is written for the -1. Okay. So I hope you understanding, and now just save this properly this code and just let me run this code now. So as you can see here, it's print for the linear search element found and index for decrement 1. Okay, and just again check here and it's perfectly great now. So now I'm next the simple change and print for index the proper index the I variable. So you can see just again select, and now I'm print for is written the I variable. So just click on. So you can see here the perfectly print for the I variable value or element found at index of 3. Actually this is perfectly. First time printed for here is the decrement for -1, and then next is print for the I is target value is 7 text print for the 3. Okay. So I hope you understanding. Okay. So next topic here I'm creating the another example for like a binary search. So binary search, unlike the linear search, binary search is much faster but require the list to be sorted. And it works by dividing the list in half and repeatedly narrowing down the search range. And it adds a time complexity for the zero log and making it much faster for more efficient for larger data set. Okay. So now let's create this example here. So first of all, I am so remove for any simple of code. Okay. So first of all, here I'm create for is a binary search. So binary is a binary search include for the array and the target value. Next, first of all, type for the low and the high range is equal to define for the 0. And next time use for the length include for in the simple of array is decrement for 1. So now properly use in the while loop and just type for the low value is greater than equal to extreme for the high range value. So now just type for here is the medium value is equal to this inside first and include for the low and then plus operator defined for the high and is divided for is the number of 2. So here I'm used for the if statement and define for in this the array index for the medium value and is equal to declare in the target value. Okay, so you can see here I'm type for the return statement and then type for this medium. So here I'm just type for in the else if statement and again create these equations for array declare in the medium and also here I'm create this is the a target this clone. And you can see here type for the low is equal to type the medium and the additional operator for 1. Okay. So you can see and type for in this else statement and perfectly defined for high value is equal to declare the medium and the decrement for 1. Okay. You can understand it. And now I am just doing here and use the return statement for decrement 1. Okay. So that's what is perfectly great in this simple of example and now I'm just uses this example. So just in transfer in the number of elements you can see first of all input for the another number of elements so first time use for the 10, 11, 15, then 23 and then 45 and also for the 70. Okay. And now just create the index. So here I'm used for is a binary search algorithm define the array and the target. So now just again remove for it is a linear and you have to include this is a binary. So we can understanding the binary search element found at index this index. Okay. That means here the Python implementation of binary search. Notice for how it repeatedly cuts the search space in half and making it more efficient than linear search algorithm. Okay. This is perfect and now just I'm saving this all code and just click on in this the run buttons. Okay. So as you can see here, you perfectly see the binary search for the element found at index for 5. Okay. That means for index the binary search quickly found the target value at index 5. This algorithm is more efficient especially when dealing with larger sorted dataset. Okay. So now that's it for the today's tutorial and today I'm creating here the linear search is simple and easy to implementation algorithm, but is not efficient for the large dataset. And the binary search was requiring a sorted list offer much better performance with a time complexity of 0 log. Okay. So I hope you properly understanding this today's tutorial. So now just thanks for watching and happy coding. Everyone and welcome back to today's another tutorial topic. So today I'm creating for the important topic in computer science understanding algorithm efficiency. So here I can analyze the algorithm using the time complexity and demonstrate their practical use case with the Python example. Okay. So first of all here I'm explaining for the algorithm efficiency. So when I'm just talking about for the algorithm efficiency, it's usually focused on the time complexity and the space complexity. The time complexity measures how the number is a runtime of an algorithm grow with the size of the input. And a common way to expose these through the big O notations, quiz help to predict performance. So you can see here is the complexity. First on the O for 1 is a constant time, O into n the linear time, and O into n square is a quadratic time, and O log n is a logarithmic time. So just focus on the time complexity and look at the two common algorithms on efficient and on less efficient, and how they perform in real world case. So first of all, here I'm used for just like for is a binary search, and in this code I'm created for the previous example tutorial. Now just I'm 18 users, and here is a binary search the time complexity for O login. And in the binary search, we set the time complexity. The binary search only work on sorted list, but is much more efficient. So repeatedly cut the search scope in half. Okay. So you can use proper understanding in this example because I'm already created now the previous tutorial. So please check, and now I'm used for the simple of example. So you can see first of all here I'm type for array is equal to define for properly the list. And this list inside and include for the range, and again create this define for the one, and also here I'm type for is it 1001. That means a sorted list of 10,000 elements. Okay, and now just I'm defining for is a target value is equal to here is a triple nine and a 9. And now if we for perfectly in this the index is equal to, so you can see I'm perfectly type the binary search this inside I'm include for the array, and also here I'm include for is a target. Okay, and now just with the print function, so this inside I'm include for here is a binary search. Okay, so is E A R C H is a binary search, and then type for is a element. Okay, so element found at index, so you can understand at index and define for this symbol of index. Okay, so you can see here I am properly create the binary search is a quickly narrow down the search range, making it much more efficient than linear search for more larger sorted data set. Okay, so you can understanding in this example, and now just can properly save this all code, and just I am click on in this the run buttons. Okay, so as you can see here is a perfectly see the binary search the founded index is 999 and the 8. That means the binary search also find the target at index for 999, but it does so much faster thanks to if the O login in the time complexity. Okay, and next time also created for the another algorithm for just the linear search. So linear search which has a time complexity of O into n. This means that is worst case scenario that to the algorithm check every element in the list. Okay. So now let's create this example algorithm. So just remove for in this all of code. Okay. So first of all, I am just remove in this code only and define for, so just type for is a linear search algorithm. So linear search algorithm and create for the array and also for the target value. I'm going to use the for loop for I in the range, and then inside include for the length of object, and then include for the symbol of array. Okay, and now I use for the if statement declare for the array index of I is equal to type this is a target value. And now I properly use in the return statement for the I variable. And also here I am created now is a return for decrement 1. Okay, that's why here the perfectly create in the same this code and just change for the list the same, and a large list of the 10,000 element and the target the same, and just change for the binary search, and here include for this is a linear search algorithm, and also going here and include for this is a linear search and the element found at the index of this index. Okay, That means for here the performing a linear search on a list of the 10,000 elements to find the value is a 999 and the 9. And the linear search check is element one by one, making it less efficient for large data set. Okay. So now just again save this all code and just click on in this the run button. So as you can see here, there's a perfectly print for the linear search element for an index for this one. Okay. So I hope you're understanding it's properly for the linear search for the element, but it also has to check almost at the end elements to get there. And which is why its performance suffer as the input size increase. Okay. So now that's it for the today's tutorial, and here I'm today properly defined for in this the algorithm efficiency. So just understanding this algorithm efficiency when choosing the right algorithm for your task. Linear search is just simple is suitable for a small data set or unsorted data. And the binary search on the other hand itself is sorted data set and is much faster for larger input. Okay. So you can see the linear search is a small data set and unsorted data, and the binary search is a large data set with the sorted data. Okay. So I hope you're understanding this tutorial. So now just thanks for watching and happy coding. Hello everyone and welcome back to today's another tutorial topic. So today I'm going to deep into the discussed algorithm, one of the most popular algorithm for finding the shortest path in a graph. And here I'm explore for how it works using the Pythons and C example. So first of all, I'm explain for overview of the discussed algorithm. So discussed algorithm is used to find the shortest path between nodes in a graph. It works by starting at a source node and exploring all possible paths to reach the destination, keeping track of the shortest known path at each step. Okay. So here I'm creating here the discussed algorithm. Let's begin by coding the simplest from the discussed algorithm and here show how I can implement it to find the shortest path in a graph with the weights. Okay. So you can see first of all I'm import for the heap queue. So just type for import and also here I'm type for this is a HEAP this heap queue. And now define for the function is state and the name is a discusters. It is a discuster. So first time type for you can say DIGKSTRA discuster and this inside I'm defining is properly the graph. And also here I'm include for in this start method. This is this attribute. And now here I'm type for is properly this is a distance and is equal to include this inside first of all I'm type for the node and here I'm use is a floating point and this inside I'm include for here is a infinity. Okay. You can understand is a infinity or is a again this so now it's not now. To define is perfectly node in a graph. Okay. And just for the next line of code and here I'm defined for again distance and use for in the start method and is equal to 0. So now create here is a PQ is equal to use this index and include for the 0 and next and use for this is a start. Okay. That's really perfectly done and now I'll apply in this the while loop and the script here is a P and Q then define so I'm just type for it's a current underscore is a distance and again type this is a current then underscore is properly the node is equal to so here I'm for the heap queue dot is typing for here is a heap pop so heap then type for pop. Okay, and this insert I'm include perfectly in this PQ. Okay, so now just again use for the if statement and then type for is a current distance is greater than used for the distance singly, and this insert I include for here is a current node. Okay, and now I'll just type for here is a continue. So, and then I'm just going for here is a next line of code. And first of all, here I'm type for is a for, and then also here I'm type for is a neighbor. So NEIGSBOR. And then type for is perfectly, you can see I'm just type for is a weighted. So now I'm just type for is a weight. So WEIGST in the graph. Okay. And here I'm include for in this the current node, and just define for this next line, and just here I'm type for is a distance is, sorry, it's not only for the distance, is equal to type for is a current distance, and pass for is a weight. Okay. And next time use for the perfectly in the if statement, and type is perfectly distance is a less than for this distance. And here I'm include for this is a neighbor's node. Okay. And now just going for again type for in the distance, include for properly in the neighbors, and is equal to type for is perfectly this distance. Okay. And next line of code here I'm perfectly used for this is a heap queue, and also here type for is a heap push this method. And this insert, and first of all create the PQ, and also uses for, you can see the distance, and created for it's a. So just I'm type for in this the neighbors, and also going for, and here I'm used for is perfectly the return statement, and declare this is a distance. Okay, so you can see this one. And now I'm just doing the next line of code. So you can see here, first of all, I'm create for the symbol of graph. Okay. So you can understand here, I'm type for the graph is equal to use this curly bracket. So in this inside, so you can see, first of all, I'm create for the graph representation as an adjacent list. Okay. So you can see, first of all, I am type for is a single quotations inside include for the index the character of A. And first of all create the square bracket. So this inside I am first to create the alphabet character for B, and then define for 1. And next time again created for this parenthesis, and include for the character of C, and then define the 4. Okay. And again created now, so use for the another character of B, then just create for here. Okay, so now so just doing this one, and first of all here okay, so you can see, first of all I am create now in this the parenthesis inside I'm include for the another character of B, and the number of 1. And also here I'm created for, you can see here another character of A, C, then the number of 2. Okay. And again printed for the parentheses include for the alphabet character of D, and also created for the 5. Okay. And now just I'm going for the next line of code. And now just I am here copy for in this line of code, and then paste for the next line, and just to change for here and use for the alphabet character of C, then use for the same alphabet for A, and then 4, and D4 is a 2, and the D4 is a 1. Okay. And next line of code I'm just again created for here is the adjacent list. So you can see declare for the another alphabet for is D, and this inside and included. So first I'm use a square bracket, and then type for here the square bracket inside include for the alphabet character of B, and then 5. Okay. And next time created for again. So use alphabet character of C for is a 1. Okay. So you can perfectly understanding in this example. And now I'm just going for the next line of code and perfectly here. So just is create this line, okay, and also going for here, okay. And next is to here I'm just type for is it perfectly. This is a start node. So START start underscore. This is a node is equal to the starting node for the alphabet character of T. And now just I'm type for here is the shortest path. So shortest underscore. This is a path is equal to type for here is a sorry. So here I'm just creating the class for is a discussor and this include for first time type for the graph and secondly I included for here it is start node name. And now perfectly use the sprint function. So here I include for properly in the shortest path. That means here I'm properly implemented here is a discussors algorithm using a priority key with for here is a heap queue module to ensure efficiency and the graph is represented as a tendency list and the computing the shortest path from the source node for each to cover other nodes. Okay. So we can understanding in this example and now just I'm perfectly saving this all code and just I'm click on in these the run buttons. Okay. So here I'm placed for the 4-line arrow. So now just I'm making check and then just let me run this code and you can see here I'm placed for the simple arrow. So now just I'm making check and then run. Okay. So now I am for here it's create and check. So you can see just I'm going for and first of all here I'm check for indeed the 4-line and you can see here I'm creately for the simple of this. So just I'm remove. And you can suggest I'm again saving this all code and just click on in this the run button just begin. So now it's perfectly free. So as you can see here is it the shortest path from the node A and A for 0, B for 1, C for 3 and the D for 4. That means for in the algorithm find that the shortest path from A to D is 4 and passing through the nodes for B and C. Okay. So now that's it for the today's tutorial and here I'm properly creating here a and explore the discussors algorithm and show for how it can be used to find the shortest path in a graph. Okay. So now just thanks for watching and happy coding. Okay. Hello everyone and welcome back to today's another tutorial topic. So today I'm properly explaining for the principle of dynamic programming in Python programming language. Okay, so today's topic I'm properly explain for and I hope you proper understanding and next tutorial and properly create the practical example of principle of the dynamic programming concept. Okay, so now let's get started. So you can see first of all I'm going for the next page and here first of all I'm explain what is dynamic programming. Okay. So dynamic programming is a technique used to solve optimization problems by breaking terms down into smaller, overlapping subproblems, solving a subproblem only once, and storing the result, and this avoid the redundant calculations, making DP much more efficient and straightforward recursive solution for many problems. So here I'm explore the principle of dynamic programming in Python just as details. Okay. So first one I'm explain for the optimal substructure. A problem exhibit optimal substructure if an optimal solution to the problem contains the optimal solution to its subproblem. So for example, in the case of the Fibonacci sequence, the value of fib in depends on the values of fib n minus 1 and then minus 2. This subproblem are a smaller instance of the main problem and solving them optimally leads to solving the larger problem optimally. So in this example, I'm properly create the next tutorial. Okay. So now I explain for another principle like the overlapping subproblems. So first of all, explain for in this overlapping subproblem. In this, a problem has overlapping the subproblem if the same subproblem are solved multiple times during the recursion. So for example, Fibonacci problem fib3 requires fib2 and fib1. When calculating the fib4, the same fib2 is computed again, creating redundancy. And another most important principle for the memo here is a memorization, is a top-down approach. First, I'll explain for the definition. Memorization is a technique where intermediate results are stored to avoid recomputation. This is done by catching the result of function calls. Next, I will also explain for the another principle for the tabulation, like the bottom-up approach. So, tabulation is another from dynamic programming where you solve subproblems in a bottom-up manner, starting from the smallest subproblem and building up to the solution of the main problem. Next, I will also explain for the another principle for the space optimization, is the most important. So, some cases we can reduce the space complexity of the DP solution by recognizing that not all stored values are necessary for future computations. So, for example, is a Fibonacci problem, we only need to last two values at time, so we can reduce the space complexity from 0n and 0,1. Okay. Then I'll just also explain for here is a state definition. Okay. So in dynamic programming, in define for the state to describe the subproblems, and the state should capture the necessary information needed to solve the subproblem. So for example, the Fibonacci sequence, the state is just the number n representing which Fibonacci number is being calculated. And also explain for here is a transition function. So the transition function depends how to move from one state to another. It describes how the solution of a subproblem can be built from solution to the smaller subproblem. In Fibonacci, the transition function is Fibonacci n is equal to Fibonacci n minus 1 and the plus for the Fibonacci n minus 2. Okay, is it perfect? And last, explain for here is a base case. So base cases are the simplest instance of the problem which do not require further subproblems to be solved. And so for example, for the Fibonacci sequence, the base case are the fib 0 and the here is empty and empty and the fib 1 is 1. Okay, so you can understand it in these tutorials the all small principle of the dynamic program, and here I properly explain for the all principle most uses principle of dynamic programming. Okay, so now that's it for the today's tutorial, and here I'm properly explain for the all principle, and next tutorial I'm properly uses for in this principle and also created for the practical based example. Okay, so now let's see this example, and now to this tutorial that's it here. So I hope you proper understanding in this tutorial. So now just thanks for watching and happy coding. Okay. Hello everyone and welcome back to today's another tutorial topic. So today I'm creating here the three fundamental data structure like heaps, trie and the segment tree. So these structures are essential for solving complex problems for efficiently. So now let's get started. So first of all here I'm create for the heaps created for the example for minimum heap. So a heap is a specialized tree-based structure that is tapped in statistic the heap property. In a min heap, the parent node is always less than or equal to its children. And here I'm using for the Python for the heap queue library to implement a minimum heap. Okay, so you can understand this. So first of all, here I'm type for you can see here is a minimum is import heap queue, and here I'm create a new heap. So you can see just type for heap is equal to use for the empty index. And we define for the variables for number is equal to, so you can see randomly use for the 5, 9, then 3 for 1 and 7. Okay. And now just insert elements into the heap. So you can apply here and apply the for loop and define for the number. Num is the numbers. Okay. And next time just to define for the heap queue dot its type for here is a heap push, and this inside I will include for the first is heap, and secondly here I will include for the number. Okay. So next is to use a remove the smallest elements. You can see here I'm type for a. So the smallest is equal to explain for declare the heap queue dot apply for heap pop method. Okay. This inside is included for simply this heap. So here is a completely create, and now just use the print function. So here I'm creating for the formatted output. So here I'm type for the minimum heap and use the clone and then square bracket inside I'm include for in this heap. And just again use the print function. So here I'm again created now. So now just type for is a smallest. So the smallest element. Okay. So element is a remove and then curly brackets inside I'm include for in this smallest. Okay. So that's using this example, I'm properly insert the numbers into heap using for the heap push, and the smallest elements is always remove the first with the heap pop and following the mean heap property. Okay. So now just I'm saving this code and just click on in this the run button. So as you can see here is a perfectly print for the minimum heap for 3759 and the smallest element remove for 1. That means in this the main heap organize the numbers so that the smallest element is at the root, which is why 1 was removed first. Okay. This is done this tutorial in this topic. And next topic here I'm creating the tries using the prefix tree for word search. So you can see trees are used to simply store and the search string, particularly useful for auto-completed and the spell check feature. Okay. And now let's create this example. So you can see first of all I am remove for in this all code. Okay. And here I create for the class name like a try node. So TRIENODE, the try node. And here I create the function is def and double dash and type for init. So next step here, first of all type the self dot use the children. Okay. DREN, the children is equal to use for the int square bracket. And next time type for you can see the self dot is type for is underscore in this the int underscore is of the word is equal to define is perfectly it's a just like here I'm type for is a false. Okay. And next time created here the another class name like a try. So TRIE. Okay. And then we can use for the functions def and then type for double dash for in this init. And this init first of all include for self dot is the root node and is equal to define perfectly into the try node. Okay. And next step here create for the another function just like it's a insert. So just use insert and this insert already included attribute is the self and then type for is a word. And just when the next line of code and here type for the node is equal to type for self dot is the root node and use the for loop and define for is a character char in the word. Okay. And now just use the if statement and then type for is a character not in declare the node dot is type for any the children. Okay. And now you can create it for the node dot is defined for the children and the square bracket include for the character is equal to type for here is a try node is function. Okay. And now term used for again the node, and just type for the node is equal to again defined for the node dot use for in the children method, and here I'm included properly in this character. Okay. And next line of code we can see. So you can see first of all here I am perfectly defined for the node. Dot is declared for each end of the word and is equal to rainfall. This is a true. So you can understand it perfectly, and now just I'm making created now. So now I use for is a search method. Okay. So first of all I am remove for in this is a copy for in this code and paste for here the next line. So you can see first of all I'm create the insert and now just do the another function like a search. Okay. So HEARCH, the search and use the Excel word evaluates, and then use a not in children and then use for, so you can see I'm simple update now. So first of all I am remove for in this code and here I'm use for the false return statement. So just on paper you can see here is the false and the node is equal to general character and the return is end of the word is true. So you can see just I'm only uses here and then remove this code. And first of all, can hyper is a return statement. That's what is perfectly done. And now just I'm use for the example. So just going the next line of code and you can see, okay. So first of all, here I'm type the try is equal to, you can use for another try method. And next time, first of all, apply is a try for using insert function, and this insert will include for the element like the apple. And next time again create into the try and also just define for in this insert and include for the shop for is a double P. And next step here I'm used for again the print function, and inside include is a try dot apply in this search, and this inside and first of all included the first element is the apple. Its output is true because it's perfect. And now just copy for in this code, okay, and paste for the next two line and change this so only use for app and then this one. Okay. So you can see here I'm completely creating this example is perfectly done, and here I'm perfectly defined a try structure and the support the inserting and the searching word. And first of all here the insert method add the word letter by letter, and the search method check if a word exists in the try. Okay. You can understand perfectly, and now just select all and perfectly saving this output and just click on in this the run button. So as you can see here, so first is the print for the true false. That means in this the word of apple and the app exist is the try, but APPL is incomplete, so it's returned false. Okay, so I hope you perfect understanding. Okay, so now just I'm going for the next example. So you can see here and create for the segment trees range sum query. These are used to efficiently query range in array, such as finding the sum or minimum values in a given range. So here I'm creating a segment tree for range sum the queries. Okay. So now let's try. So you can see, first of all, I am remove for in this code. Okay. So just I am remove, and first of all here I'm create for the another class. Okay. So just to remove this, first of all here I'm type for is a segment tree. So you can understand it's a segment, it is a tree. I'm just doing the next line of code, and here I'm type for div and then double dash for init already defined for the self, and also here I'm include another attribute like a data. And first of all we have type for the self dot defined for in is equal to declare this link inside into for the data. Okay. And next step here I'm just type again for the self dot is type for in this country is equal to. So square bracket inside include for the 0 and the multiplication sign and then define for the 2. And again the multiplication then self dot is different for n. Okay. And now just in create for. So just build that tree. So you can understanding here and apply is it's perfectly apply the for loop and define for I in the range. And then inside first I'm going to put for self dot in. Okay. And now just perfectly type for here the self dot is used in the tree. And here I'm applying for just define the self dot notation and then type for in the class operator for the I variable and is equal to define for perfectly the data and this include the I variable. Okay. And this doing the again apply for the perfectly in the for loop for I in the range. So first of all here I'm include for the self dot is defined for in minus 1 and again created for the 0 minus 1. Okay. Sorry, it's not 0 minus. So first I'm only use for 0 and minus 1. So now just the next line of code and here I'm defined for the self dot is used in this the tree and just create the square bracket instead of include for the I is equal to type for perfectly the self dot is defined for in the tree and use a square bracket inside will include for the 2 and multiplication sign for I variable. And just again created the class operator defined for the self dot is type for this tree and then include for the 2 and multiplication sign for I and the class and just going the class operator the 1. Okay. So you can understanding in this example and here I'm perfectly create the segment tree. And now here I'm also created for the range sum and just make this code and copy the previous example and just paste here. Okay. And now just doing for English. And just going the next line of code and here I'm used for the perfect example and just I'm remove for in this the all of code. Okay. So first of all here I'm type for just simply the data and is equal to type for the square bracket inside first and type for the 1, 3, 5, 7, 9 and 11 and here I'm used for the 11 for randomly and simply here I'm used for the segment underscore this is a tree is equal to and properly here I'm type for in the segment tree this inside the input for this data. Okay. And first of all here is the spring function and now we use for the formatted output. So you can see here I'm type for the range of sum. Okay. And then parenthesis inside include for 1 and 4 and use the clone and then again use the curly brackets this inside and include for the segment tree dot apply for here is the range sum and then include for the number is 1 and 4. Okay. So you can understand is perfectly clear this example and here I'm properly build this the segment tree to perform the range sum queries. And the range sum method allows you to find the sum between the two indices efficiently. Okay. So you can see here is properly create this example. Now I'm just going to save this all code and just click on edit the run buttons. So as you can see here is a perfectly print for the range for 1 and 4. Its total output for is a 15. Okay. So you can see the segment tree allow for efficient querying of range in logarithmic time. Okay. So that's it for the today's tutorials. Now just thanks for watching and happy coding. Everyone and welcome back to today's another tutorial topic. So today I'm going to explore for the technique to optimize algorithms for better performance in Python. From redundant the time complexity and now here I'm using example for the small tweaks can make a big difference. So first of all here I'm creating the example for optimizing with here is a memoization. Okay. So here I'm used for the best dynamic programming principle. So all the powerful optimization technique in memoization which store the result of say function calls and reuse them when the same input occurs again. And let's see these in actions using here is a Fibonacci sequence example. So you can see just going this inside, and first of all here I'm creating the without for the memorization. Okay. So first of all find for the function and then type for is a Fibonacci include the number of n. Okay. And now I'm use for the if statement for the type is n is less than equal to or 1. Okay. And now just use for perfectly the written statement for 1. Sorry. And just bring the next line of code, and here I will use for the begin use in this written statement, and then type for here is a Fibonacci for the key, and this inside of wait for in -1 and use here. So perfectly use the plus operator and then type for p for in -2. Okay, this is perfect. And next time create the with the memorization. So here I'm simply using the memo and is equal to using into curly brackets. So now you create again the function is give underscore speed. Okay, so is a Fibonacci and use for here is a memo, and this entire include for the in. So it now use for the if statement for if in the memoization, and going use for the return statement, and also here wait for the memo for in. Okay, and just I'm making use for here the if statement for in and less than equal to 1, and it can use in this the return statement for in. Okay, and next line of code type for the memo use index and include for the in, and is equal to type of perfectly the Fibonacci the Fib memo, and included for here is perfectly in -1, and use the plus operator, and it can create it for Fibonacci for the memorization, and here type for in -2. Okay, so it's a perfectly great, and I'll just use the perfectly written statement, and the type for is a memo index include and define for the in. Okay, is a perfect, and next thing created here is a test performance. You can see here I'm just include for perfectly in this time. Okay, and now I'm just create the test without for the memorization. So you can see here first of all I'm type for is a the variable name for start underscore exit time, and is equal to define for the time dot live for individual time functions. So you can see here I'm using the function. So now just I'm type for here is perfectly. Here you can understanding is a Fibonacci of the 35 is without for the memorization. So now just I'm including for here is without. Okay, and then I use for the curly brackets, and this includes the first time use for the if and apply for the number of 35. Okay, and next step I use for using the print function, and here I perfectly type for this is a time token, the time token, and include it for the curly brackets is inside and include process time, and here is the time functions. And also just here type for the subtractions, declare the start time is clone 0.4. The 4 is floating point, and then here outside I create for is perfectly this is the seconds. Okay, so you can understand it, and just I'm going to next line of code, and first of all here and create for the with the memoization. So you can see here I'm just copy for in this code. Okay, and then paste for here the next line. So you can see here I'm just simply change the first of all is the start time, then time function, and the Fibonacci 30 is a with for the memoization. And you can see just I'm removed for into the feed, and here I am included for here is feed underscore memorization. This means that I'm included for the 5. And again going here and just use the time the minus the start time with the plotting point is as it is. Okay? We can understanding this completely done in this example, and here I am properly calculate the 35 Fibonacci number with and without the memorization. And you can see the memorized version drastically reduce time taken by sorting the intermediate result. Okay, so here is a perfectly great, and now just I'm saving this all, but I'm just click on in this run buttons. Okay, so now just wait here and you can see the output. So first of all, here is a perfectly free. So we will answer 35 without this number. Time taken for 4.6. It's print for the floating point number. And with for here is 9 is as it's the same, and the time taken for 0.0 seconds. That means in this the memorized function runs much faster because it's avoid for the redundant calculation. And the memorization is particularly useful in dynamic programming and the recursive algorithms. Okay, so I hope you perfectly understanding for in this the perfectly explore the key optimization technique like the memorization to reduce redundant calculations. Okay, so this stage can make your algorithm run more efficiently. Okay, so now just thanks for watching and happy coding. Everyone, and welcome back to today's another tutorial topic. So today I focus on memory and the space optimization strategies in Python programming. And here I cover and explore for the two key technique to reduce the memory use in your program. So now let's get started with some practical example. So first of all, here I'm using the generator for memory efficiency. First of all, the Python generator are an excellent way to optimize memory use, especially when working with large dataset. Unlike list generator, don't store all values in memory. They generate values on the time fly, making them much more memory efficient. Okay, so first of all, here I'm using a list in efficient memory use. So first of all, here I'm type for the nums underscore, this is the list, is equal to, then square bracket inside I'm type for I for, then use for in this I, variable and the range, and this inside I'm included for here the random use for in this number. Okay, and next I'm use this print function, and then here I'm included is perfectly this is a memory use, so U SAGE uses of in this the list. And here I'm included the perfectly numbers list dot is type for here is dash, double dash is used for the perfectly, you can see this is a, so you can see I'm only used for, and in this the size of, and just in this outside I'm defined for is perfectly it's a bytes. Okay, and now just using a generator memory efficiency, you can see I'm again type for the numbers of a generation and is equal to, then inside I'm just type for I and the for loop used for I in the range, and this inside I'm again uses this parenthesis and randomly use this amount. Okay, is a second, time of second, and use for in this the print function, and this inside I'm included for again. So you can understand here I'm type for the memory uses of the generator. Okay, okay, so you can understanding the generator, and this inside first of all it's not now, so uses the brackets, this inside I'm include for the numbers generator dot apply for is a size of, and also created let's say bytes. Okay, that means in this simple example just compare the memory use of the in this the list A versus a generator that both handle on the million numbers. Okay. So now just save it perfectly in this code and just click on edit the run button. So now you can see here, see the results of memory use of the list for 8448712 byte, and the memory of the generator is 176 byte. Is perfect. Okay. So you can see this is here is because the generator turns on at a time without loading all the values into the memory at once. Okay, so it's perfect now. Next topic here, I'm also using the slots to reduce the object memory, the footprint. So in this term, strategy is using the slot in class definition to reduce the memory footprint of the object. By default, the partner store object attribute in a dictionary. This will take up more space, and the slot allows you to define a fixed set of attributes, reducing the memory uses. Okay, so first of all, here I'm creating the class without the slot. Okay, so you can see just I remove for in this all for and first I create the class name is a regular class. Okay, so you can see here I'm type all this is a regular class, and then use for the function is def underscore step the function, and then init. So this inside and create another attribute. The first one already created the self and second a different name, and also create the age attribute. Okay. And I'll just type for self dot is defined the name is equal to this name, and also created for the self dot age is equal to in this age. Next line of code here and create a class with the slot. Because here I'm create another class name like A, and now I'm create for the class name is a slot class. Okay. So here I'm create a slot class, and then going the next line of code, and here I'm type for underscore. This is a slot as a slot underscore, and just going and is equal to here I'm type for the square bracket inside first include the name, and secondly here I'm include for perfectly in this the age. Okay, and just going the next line of code, and here first include the another function, and then type a double dash init, and here I'm include for again first time apply the name attribute, and secondly include the age attribute. So you can see first of all type for the self dot define the name is equal to for in this name, and secondly I'm create here, and just going the next one, and here I'm type for the self dot define the perfectly age is equal to in this age. Okay, it's perfect. And now just import for the memory comparison. So you can see here first of all here I'm type, so just going here this type for import is just SYS. Okay, and you can see first of all here I'm type for is a regular is equal to, so you can see here I'm type for the regular class. So this inside first of all I include the first person name is like Alice, and include for the Alice age is 13. And next I'm also created for here the slot underscore. This is class is equal to, so first of all here I'm defining for the slot class, and here I'm create another person name, so just type the person name like a Bob, and include for the Bob is a 35. Okay, and just now I'm print for into the output. So first of all here I'm type for you can understanding it's a memory use of the regular class. Okay, the class object, and then define this curly bracket saying this equal to SYS dot apply in this the get size of, and this inside I'm include for here is a regular class, and this term typer is perfectly it's the bytes. Okay, and now just I'm copy for in this line of code and Then paste for the next line. So just copy and paste for here the next line and just remove for different here and use the memory use of a slot class. So you can understand you the slot class object and also uses. So now just remove for in the regular class and include here is a slot class. Okay. So you can understand here is a perfectly clear and here and properly compare the memory use between two class object like one using a regular class and the other using for the slot class. Okay. So now just I am properly saving this all code. Okay. So just select all and saving this code and just click on in this the run buttons. Okay. So as you can see here, it's a perfectly print the output. Supposed to print the memory use of the regular class object, the 48 bytes, and the memory use of the slot class object is a 48 bytes because it's same here. Okay. So just here, I'm just created again. So just change for you can see just remove and apply for again. Just use for here is the 22 and then again saving this all code and just click on in the run button. So now let's see. So you can see here is a perfect see the result. Okay. So I hope you perfectly are understanding this today's tutorial and here I'm properly covered the two essential memory optimization stages using the generator to handle large data set efficiently and utilizing the slot in a class definition to reduce object memory uses. Okay. So now just thanks for watching and happy coding. Okay.